Hello everyone, welcome to the live stream. Hi the Tha, hi the Object, hi the Bodrin, hi David, hi the Timon. Thank you for reminding me to switch to live chat. Hi the Frederick, hi the It Goes Boom, hi the Tattoo Bot. Hi. Hi everyone, welcome. Tha, yeah, you missed the last live stream. I was having so much fun. You know, playing about most. Hi Eti.
Hello.
Hi.
Hi.
And so today, this might be a day 722 or 723, depends how long this live stream goes, honestly. Mostly waiting for Flame to join in. There's gonna be a Flame stream. It's a great kind. Also, in the meantime, of course, some animations to render. I've been rendering a fair few, but it's going a bit slow. I need to pick up the pace.
Will you argue about mods with Flame too?
I've already done it. Flame already agrees with me.
What?
Yeah. Flame's already...
What?
Yeah. I've already went through the phase of complaining about stuff. I don't know if you remember, but one of the first live streams on which Flame joined was just me complaining about most for 4 hours, right? Or 3 hours? Or something measured in hours. Meg, I have a question. I believe that temperature is the movement of atoms. One professor says that the movement of atoms... Wait. With that temperature, I believe that temperature is the movement of atoms. One professor says that the movement of atoms is temperature. Which is correct? Hold on. I believe that temperature is the movement of atoms, but the movement of atoms is temperature. What's the difference between the two views? You don't have to apologize. I haven't even got, I was just reading the question. You don't have to apologize. I just don't understand the difference between your two views. Movement of atoms scales with temperature. Oh, I see. Well, that's because temperature, if I'm not mistaken, can be it's proportional to more than just the... Well, I mean, movement of atoms, I guess, is then... Yeah, the thing is, movement of atoms, you can express it in terms of kinetic energy. So when you have an atom, right, it's moving, then that's just kinetic energy. You measure that in joules. If you have like 3 times as many atoms, then that's 3 times as much kinetic energy. If they're moving twice as fast, then that's even more, twice as fast of kinetic energy. So when it comes to movement of atoms, that is kinetic energy. Temperature is not kinetic energy, however. Kinetic energy, if I do remember correctly, was mass, distance, or length squared divided by time squared, whilst temperature is just T. And so basically, the reason why there is a difference between temperature and this kind of kinetic energy is because of entropy. So this concept of averageness is important there. So temperature, basically, you should think about it this way. The reason why temperature scales up with the movement of atoms is because you also add an entropy to the mix. Pun intended. And so when you consider entropy, you realize that the concept of temperature is a bit different. It's thermodynamics. I won't sit here and pretend as if I know exactly the math behind, because it's awful, but it's because of entropy, thermodynamics, and information theory, all the other stuff. Hi, the lemon. Hi. Heat versus temperature thing. I don't think quite, because I'm pretty certain heat is just transfer of temperature. What's my favorite constant? Speed of light. It's the best. It's the best constant.
I like Planck more.
You like Planck's more? Planck is fine, but I mean, with Planck's, it's kind of it's all over the place. Like, it appears in all sorts of equations, but then it's like rescaled in a weird way, where you have the reduced Planck's constant, and even the reduced Planck's constant can be further reduced. If I do remember correctly, with uncertainty principle, it was delta x delta p is equal to reduced Planck's constant divided by 2 pi, if I'm not mistaken. And like, you just keep reducing it. Hold on, am I remembering this correctly? uncertainty principle. Let me see. Oh, I was so close. That was good. Now I'm good at this. Also, right here, not deltas, only sigmas. Oh, I am just incredible at this. There we go, and the reduced Planck's constant is just Planck's constant divided by 2 pi. So it's just kind of weird because you basically have in the uncertainty principle Planck's constant divided by 4 pi. But I mean, I get it. They wanted the Planck's constant to be different because of the black body radiation, which I mean, no way! Scientists chose the less convenient option because of historical usage. Well, there, I guess, must be a first time for everything.
At this point, I'm not even gonna say my favorite constant because, like, why did I just set theirs and make it just straight up tell them why they're wrong?
What do you mean wrong? You can't be wrong about having a favorite constant. I just gave my reason why I prefer speed of light.
Planck is the only one I remember.
No. Well, I mean, no. I mean, you should remember speed of light as a constant.
It's a constant, but it's like so.
But at the same time, the other
It's
ones
like
are
1
just.
plus 1. It isn't a sum in my eyes.
I mean, the thing is, with other concepts that are a bit more obscure, like cesium oscillation, like hyperfine cesium oscillation. Not many people know that. Boltzmann is a bit weirder. Also, not that many people care about. Lumens are fucking non-existent. So is that kind of movement temperature or the movement influenced by temperature, meaning that temperature is a completely different thing? It's not completely different, but it is related. How should I put this? Okay, so David, when you say movement of atoms, right? Then what you actually mean is kinetic energy. And kinetic energy is not the same thing as temperature. It's kind of the whole biggie of thermodynamics. That is because, if I do remember correctly, temperature divided by kinetic energy, that gives you entropy. I don't remember what the symbol for entropy was. Probably H? No, I don't remember.
It's either H or S.
Never mind, I do remember then.
Like,
Maybe.
one is entropy and one is enthalpy. I don't know which is which.
My favorite constant is a Euler-Mascheroni constant. Really? It feels very tame for you, Lemon, I do have to say. For me, it feels, because it's like one of the most common and important constants of mathematics. It feels very tame. Which theory of the death of the universe do you think is true? Great rip, heat death, or great bounce? I think that, well, personally, first of all, I should say that the best evidence we have is for the heat death. That's according to our current theories. And yeah, there are then additional theories, great rip, great bounce. What I, however, think is that it's going to be none of those. And I think it's just going to be in some different way. First of all, I genuinely believe, or at least I think it's probable, and I really like the idea that entropy is reversible. I really like that idea. According to our current theories, I should what?
Watch Tenet.
Yeah, I know. Everyone keeps telling me that. It's on my list of things to watch. But basically, I really like the idea that entropy is reversible, simply because then you wouldn't need the death of the universe. You wouldn't need one. And when it comes to infinities in mathematics, basically the laws of infinities are a bit more confusing than we give them credit. So you can have stuff that are like scaling up for all infinity or scaling down for all infinity and never actually reaching the end of the scaling. And so entropy is weird because entropy actually gives you a limit. There is a point at which entropy cannot go any further, heat death, basically, where all the useful energy is used up and all the entropy is maximized. However, if there is a way to reverse entropy, then you don't need heat death, and what's more, you can just keep the universe forever. Forever expanding, even, and still being interesting. I made the gamma one, not the. Oh, I know, Lemon. I've made a video about it. I know the difference, but it's like one of the more. Let me show you. When you have Euler's constant, where is it? That was right. Oh yeah, the fact that the gamma has been called the third most important mathematical constant after pi and e. It has been like called one of the most important constants. Do you remember the one thing I made and sent all those integrals? I do remember that. I don't remember what those integrals were because I mean I don't have that kind of memory. My favorite constant is the ratio when I'm ratioing people on different social media platforms, and the ratio of my likes to their likes. That's my favorite constant. I'm not rendering anything. 31 to 70, that's finished. What's next?
You know what? I decided that I'm interested in your opinion. My favorite constant is the fine structure constant. Why am I wrong?
I haven't heard of that constant.
It's the most intriguing constant of physics. It combines all the fields of physics, and it's roughly 1/137, and it's dimensionless, and it's weird, and it's just there, and it's just somehow it just spawned there, and now it's there. That's all to it.
Strength of the electromagnetic interaction between elementary charged particles.
It's just a cool constant.
Make it, what's your opinion? Avogadro's number, don't get away from it. Watch the previous stream.
No, we should go back to that stream. It was pretty fun watching you two debate.
It wasn't a debate. A debate would suggest that, because listen, this is a single continuous rant I've had for like what, half a year now. I just cut away between multiple live streams.
Well, yeah, watching you rant is pretty fun. So yeah, so someone start arguing about moles again. Someone bring them up.
I don't want Flame to join in again on Miro. I mean, we can do it. It's I really don't have much more to add. I'm really happy that I've reached the ideal gas law, because the ideal gas law puts it as simply as it can be put. Basically, you have two statements, and one of them has to be wrong. Either the ideal gas law, or number of molecules has to be. You have two statements. One of them is ideal gas law. The other one, number of molecules is just equal to the number of molecules, and one of them has to be wrong. Otherwise, either that or mole is in the unit. So yeah. Advanced version of the gamma function, which is generalization of the factorial, but I was specifically using the incomplete gamma function. So this is kind of like the electric constant, except instead of like the electromagnetic field is like interaction with the electromagnetic field. Timon.
Yes, sorry. I'm paying attention. I promise.
I was talking about defined structure constant.
Chad got scolded in class.
Yeah. The defined structure constant is kind of like electric, because I know the electric constant. I know that one, the vacuum permittivity one. It's kind of like that.
Yeah. It's just it's kind of like that, but it's not just, but yes, and it's also weird because it's. I don't know why it's weird. I once read a physicist ranting about pages and pages and pages of why this constant is so weird, and I just loved that rant so much. It was so beautiful, but I've read it ages ago, so
I
don't
like this
remember every
sentence.
detail, but
I like this sentence right here. In the system of atomic units in which E is equal to m is equal to reduced Planck is equal to 4 pi epsilon null is equal to 1, the expression for the defined structure becomes. Why shouldn't C also be 1? Hold on, I don't get that. Why wouldn't you also chuck in a C to be 1 over there? Oh, because atomic... Wait, do atomic units really still call C something different?
But we always work with that system, which is very funny.
I mean, no, this makes sense. You're basically normalizing it, which, I mean, I'm all for it.
Yeah,
But why? But you don't normalize the C?
I mean, as long as you don't go relativistic, you don't need to.
I guess, but then
mean-
all the velocity is gonna be really ugly. Everything dealing with velocity or movement, for that matter. Because then you would need to. Because then you would need some kind of unit for distance. Create superposition proportion distribution.
Honestly, I have no idea, because since we don't use numbers, we don't really care about the exact units.
I mean, no, that's the whole point of normalizing, right? You set all the units to 1, then you don't need any constants to switch between them.
Yeah.
So if you set everything to a 1 in its own respective like unit, then if you want to switch from I don't know, from something to joules, like you don't need to switch from electron volts to joules, because you only have one unit which expresses energy, and that unit will be equal to 1 of everything, because everything else is a 1.
No, it's a very good system. I really like this system. It's just no. I think rather the funny part is that we treat this system so trivially. Like yeah, that we just don't care about units anymore.
open the file. Wrong frames. Frames right here. Huh. That seems fine. That seems completely chill and fine. That is not fine. David, I have no idea what you're talking about there, to be honest. I think you either need to take your meds or stop taking whatever pills you have. Spectrum views will be good to see why you render episodes 24/7. I have RTX 3060 and that's all I remember. Welcome back, Lemon. What is this video about? Oh, this video? It's just an excuse for me to trash on the mall. Like, technically it's about, you know, all the constants, the basis I said, but to be honest, it's just an excuse for me to trash on the mall. The whole video just ends with it, like, you know, I first have the speed of light, then the cesium frequency, then the Plancks, then Boltzmann, then I skipped over one. Light, cesium, Plancks, Boltzmann, elementary charge. Oh, that's the one I always forget about. Then after that, skip over Candela, and the last one will be Avogadro's, and I just use it to trash on them all. Oh, hell yeah, indeed. Alright. The only problem is that I need to render a whole bunch. Well, I mean, that's kind of typical of my videos, I guess. When did I upload the last video? Well, you just what?
Have this urge to just, when you upload your next video, to just comment that this video is trash. By the way, I didn't watch it. I just wanna write that comment.
An average mall user.
Wait a minute, I could do that.
Is there a theory, more of a branch of the theory that says that from every different thing that can happen differently, it happens, but on different timelines? The theory is that, yeah, you mean collapse of the wave function thing? I think there was something with the collapse of the wave function that, like, goes into a long time. Well, I wouldn't open consciousness there, David, because we have no idea what consciousness is. Generally, if you see someone mixing abstract human scale things like consciousness with quantum things like collapse of the wave function, then that's a red flag. That means they're probably bullshitting you in some way. So I wouldn't say that. However, there is a theory that the like multiverse happens. I think it was collapse of the wave function. Let me look it up. Was it wave function collapse? You read dark matter. Dark matter? I don't even know what that is. Funny. What do you think about gravitation constant? Oh, you mean the G force of gravity? The G in force of gravity, is that the one? No, redirected from force of gravity. No, I mean like force of gravity, the equation. Where is it? Modern research? No, I mean Newton's. There we go. I mean this one. Usually when you see constants like these, so basically constants that are meant to scale something, that usually just suggests that the theory is either incomplete or incorrect. When you need to scale something, basically. And in this case it was, because then general relativity came along. With fields.
I'm not sure what you said, but I heard woof woof.
From whom did you hear that?
From you. I'm not sure what you said, this is just what I heard.
Time and you. Get your mind out of the gutter or something, I don't know.
What?
Yeah, how it's called the primary language study
You're
is...
supposed to talk. Mind out of the gutter.
You're the ones who associated, who just went from heard dog noises or mine must be in the gutter. Like, Jesus Christ. You're the weird ones here.
You know, your stuttering isn't really
Don't
helping
make
your
it weird.
case.
I'm not weird. I'm insane.
Your stuttering really isn't helping your case, I have to be honest.
You always stutter. You know that.
I know,
doesn't
that's what's so funny about it. That's why it's so funny when you try to explain yourself. No, I'm so tired. Okay. A new science recommendation is certainly by a really interesting book that takes place in the future, more about ethics than sci-fi, but has a lot of sci-fi elements. I thought through images of case files and shared instead of regular storytelling formats. Awesome. That does sound interesting. I know, I don't really read books. Ain't got time for this. I think books are just a fad anyway. Just like the internet. Keep getting this by Hobby Back and welcome back, Lemon, again. Alright, you know what, since I'm rendering, might as well just get to work on something, because, oh my goodness, I'm wasting time, pointless. And that work will be on the video, which I really wanted to make, but I haven't even did the plan for it. That's the one. There we go.
When Q&A.
Oh, I haven't edited still, have I? Oh, fuck.
Nope. You're way past the 15,000 mark.
Well, I mean, way past 2,000 over it, it's fine. 1,000 one way, the other way, doesn't matter. I can edit it today. I will. Just... I'll edit it today, unless I once again pass out drunk. I mean, pass out tired, asleep on the couch.
Same
Yeah.
thing.
No.
Yeah, I mean, it is in Poland.
Books are so 500 BC. Yeah, I mean, yeah, come on. These hipsters with the books nowadays. I think I go to sleep in like 10 minutes, gonna wake up early tomorrow. Well then, good night, David. Good night, have a good one. Again, to clarify, I mean the order mastering is defined by gamma and not the... Lemon, I've made a video on this. I've made a video in which like the first joke was that I was explaining the Euler's constant and not Euler's number. You don't have to tell me. I know. Oh, matrices. What else was there? From matrices, the plan was to go linear maps, matrices, then... Oh, the name of the function, which I obviously forgot, was anti-symmetric multi-vector function, I think. I don't think it was a multilinear map. Might have been. It kind of looks like it, but is it the same thing? Anti-symmetric on linear maps. Okay, we're looking for the anti-symmetric one. Bilinear map? Oh my god, is that the...
I just muted you, shut up.
Timon, you okay?
Nope, I just muted Facebook. Yes, Hungary still uses Facebook. Everyone in Hungary uses Facebook, and it's still not shutting the fuck up. So I just killed it with fire.
If you just like delete Facebook,
then nobody will reach me because you know everyone here uses Facebook for some reason.
I know, switch over to WhatsApp or something. Maybe they got that.
Nope. No one has WhatsApp in Hungary. Everyone uses Facebook Messenger. And
Yeah,
actual Facebook, like the Facebook.
That's actually pretty... I mean, Messenger is pretty common. Facebook, not quite, but Messenger, yeah. I do see a lot of people using it.
I killed it with fire.
Do you think
How is
math
it
can be
still-
proven from nothing and we're just living in some random part of a 4D sine wave? It cannot be proven from nothing. Because, I mean... Well, nothing is nothing. You can't really do even logic from nothing. Because, I mean... Oh,
Alright, so prove 0 equals 0.
like, you can't do it from nothing. Yeah. Nor can you actually prove it. That's called an axiom. But, like, math can be proven true with no axioms. It cannot. It needs axioms. It always needs axioms. So, for example, if you have something as trivial as... I don't know. Let's go for 1, simply because it's... 0 might have some weirdness going on. Like, if you have 1 equals to 1, you can't actually really, as far as I'm aware at least, you can't actually prove this, or at the very least, I'm using 1 equals 1 as a placeholder here. In this
And
case,
simple.
in this case, this is, I'm just using this to refer to like a basis. You will have something that you just assume as an axiom, in which case you use this to then prove other things, but you won't actually be able to prove this thing. There was a thing called incompleteness theorem, I think. It was kind of that, but I don't remember. Boltzmann brain opinion. I know exactly what I can. Is Boltzmann brain the one in which you just have randomness and that creates consciousness?
Yeah.
Was it? Am I correct? I've never heard of Boltzmann brain.
Yeah.
That was just an educated guess based on who Boltzmann was and based on what makes a brain.
Yeah,
That was correct.
Wow, that was a really educated guess. Then I'm good at this. Yeah, I think it's kind of valid. I mean, like statistically, yeah, if you have an infinity. What if 1 equals 1 is unprovable but true? Well, that's the pickle there. You see, the pickle I have with that is that saying true, I don't really like it, because I mean, true doesn't actually kind of exist. You see, like, given a certain amount of axioms, you can say if based on those axioms, given the certain rules, if something is true. However, something being true in a vacuum, that kind of loses its meaning. Because 1 equals 1 is unprovable but true. You would need to define true there. In order for you to define true, then it would no longer be in a vacuum with nothing. You need something, just for the sake of, you know, saying what even does it mean for something to be true. That's why you can't really create math out of nothing. Even logic. Like, the thing is, it is possible that logic is just straight up incorrect. Or gay up incorrect, whatever you want. It's possible. It is possible. Because at the end of the day, maybe there is an alternative. Maybe there is a sequel, a logic 2 we just haven't thought of yet. A better sequel. Like, we can't rule out those possibilities. Like, yeah, logic is the best we have so far. It's incredible. But at the end of the day, I don't like it when people say that, no, it's been created from nothing or from vacuum, because it's not really. It's the same, to me it seems similar to what Euclid thought, you know? With Euclidean space. Like, for Euclid, who was living in our universe, it seemed obvious that these were the rules for Euclidean space. But then it turned out that they can actually have it more general. You can actually create a more general concept of a space. Now, that's not to say that math or logic is worthless, because it's certainly extremely useful, but it's the same thing as with elementary particles. When it comes to the standard model, it's not like we're just going to discover the 18th particle, just like that, because that's not how it works. The standard model is a model in itself. However, just because we can't just discover an 18th particle doesn't mean the standard model is correct. In fact, there's a lot of people trying to prove it wrong. It's kind of a biggie. Wait, bilinear form, is that the one? Hold on, let's check the definitions. So this tracks so far. This tracks so far. But then, okay, you have symmetric, so it's anti-symmetric bilinear form, right? I'm just gonna ask Roblox. What do you think about Dietz theorem? You're just gonna keep giving me fucking names to look up. Here, I can't even make an educated guess because I don't know who Dietz was. Wait, is that with T? Extension theorem, topology. Oh my goodness, topology. I'm not gonna be good with topology. Or cross subset can be extended to the entire space, preserving boundaries when necessary. I don't. Why is Pavel there? Who's G? Why is I'm confused. It says the following: these nuts got them. Fuck off. Okay, you got me there. Can we stop with my opinion on theorems? Like, the theorem situation is crazy, I get that, but I mean... What am I looking for? Determinant, right. Let's go right here, determinant. I'm not looking for geometric meaning. What we are looking for instead is the definition. There's the Leibniz formula, however... We'll be careful exactly is... Is the Leibniz... Oh wait, no, that's all just Leibniz. Okay. Definition. Where's the determinant? Yeah, but like, where's the? I'm missing the definition. A is another. There are various equivalent ways to enter those cameras. Everyone with the same number of rows of colors, determinant can be a Leibniz form, extra form, determinant comes with characterization as the unique function depending on the entries of the matrix satisfying certain properties. What are the properties? Definition of the determinant. Hi Mark, hi. Welcome. And bye David. Determinant definition. Library text, save me. What is a determinant? It's a real number. Determinant is a real number, great. It's defined via its behavior with respect to row operators, okay. We use a row reduction to compute it. We go recursive formula for determinant. Okay, properties, yes! Alright. Doing a row replacement on A does not change the determinant. Scaling a row of A by a scalar C multiple multiplies the determinant by C. Okay. Swapping two rows of a matrix multiplies the determinant by -1. The determinant of the identity matrix IN is equal to 1. Is that the entire definition?
I
Because
think these were just the properties.
this says definition.
Then I guess, who am I to argue with library text?
It feels a bit simple. Also, it feels like, wouldn't we have multiple determinants for a single matrix then? Hold on, Mark. What did you just say? Whoa. I mean, your stream of Graph stream. I can ask a Graph to join in on my stream. How popular is a Graph nowadays?
Who's graph?
Oh, someone who has 10 times more subscribers than me. A Minecraft YouTuber. They have 10 times more subscribers than me. Yeah, that's not gonna work. Mark, hold on. Did you just say tomorrow I'll be meeting a Polish girl I love? Kinda scared she is similar to you. Oh, then you should be scared. But I mean,
I'm scared of Polish girls.
I'm scared of women in general. Terrifying. And men too, honestly. If I'm being honest. And non-binary as well. I mean, come on.
You don't discriminate.
I don't discriminate. I'm just antisocial. It's probably just actually make it. No, I wouldn't be meeting with people in real life. I live in the machines. I'm just a conscious machine spirit. I wanted to tell you a joke about food flavors, but I worry it would leave a bad taste. We signed number, right? Okay. Operator as your number. Is geometric? How the word difference and how to compare it. This is so confusing. There is more information on computing determinants than what they are. Like, it's cool that we know how to compute them, but I mean, what the fuck am I even computing?
It's the volume of the matrix or something like that.
Well, no, because the volume you can just get it with outer products. Right here you have a sign. And like, there must be a reason for that sign, because otherwise we wouldn't have the determinant.
Yeah, because if you flip it the other way, it's technically negative volume. That's why it's not a volume, it's like a volume, or rather how much the volume of the matrix changes the parallelogram of something like that. It's basically volume. I'm a physicist, so it's volume enough for me to not care.
Yeah, but unfortunately I'm doing a math video, so I need to approach it like a mathematician.
Sounds like a you problem.
I get why Roblox is insane. I just get it. And Mark is wishing you a happy birthday.
Thank you. Happy birthday to you too.
What songs to the young humans, in quotes, of Poland listen to? Is there something like Polish reggaeton? I don't know, mate. I don't know. I really don't know.
Oh my god, one time Sally just started ranting me about how bad Polish pop music is. Like, just started ranting about hating Polish pop music. Which is, I didn't even know that it existed, but yeah. I listened to it. I don't see why it should be more hated than any other pop music.
There's exceptionalism, you know. Every single person from every single country thinks that their country is special. I was overcome about patriotism. I don't care about well, I do care about the intuitive way, but I care about the intuitive way to think about determinant, not the absolute value of a determinant. If you think about the intuitive way, if you think about it like you can't think of determinant in terms of an absolute value of determinant. I mean, if you think of a sine function in terms of its absolute value, then that's just a constant. Formulas like messy, complicated. There's no natural way to interpret the value. Damn it! What way is the this calculus first line? It's hard to believe things are going to just it. A function takes n vectors, the n comes from a matrix, and returns number. Okay, yeah. Two rows of column changes the sign, yes. I remember Reblax was giving me all this. Okay, that's good.
Oh god, I just took one look at the chat and just saw them talking about trans women and scissors again. Jesus. Okay, this sounded very bad out of context, but if you know the context to it, it's not bad. I mean, it is way worse. I mean, no, I mean, so it's not bad on my part, okay? It's bad on.
It's incredible how you can dig a hole for yourself, like unprompted, you know? It's honestly an incredible ability how you can. I don't mean to be that guy, but I mean, I don't know how you can just join in on streams confident and then just every single time dig a complete hole for yourself. You constantly keep saying like you're worried you're gonna say something you're gonna regret in these streams, and then just continuously unprompted dig these holes for yourself. You can't escape from. Like, I called you a racist on one of these streams, and you just took off. Oh, Mark just said, "What's your opinion on competitive racism?" Well, I lost. I lost at one point, so I'm upset with it. Make it. What's your opinion on amphibians? Not a big fan. Not a big fan. Too watery, you know. What's your opinion on salamanders? I would give them a solid 6 out of 10. You know, not quite geckos, but close. Would you rather not have to pay any taxes, but you lose half your knowledge, or you double your current knowledge, but pay double of all taxes? I would double my tax. What do you mean? I'm not anti-taxes. It's not a tough question. That although that's called paying to get into a university. What you're describing, basically.
You don't like amphibians, huh? Like I
too
thought that
watery,
you were
you know, too watery.
Yeah. I always thought that you were bisexual, but apparently this has been disproven because yeah.
The ultimate bisexuality test.
I don't know. I read it. I saw it on Reddit, and that it and they say it works. And I would a Reddit user on a meme page lie?
Listen. I am bi. I'm a bilinear form, okay? Make. What's your opinion on opinions? I don't like him. I think it's awful. You know, it's people just should having opinions. Yeah, but like transfer taxes would be much more than tuition to anywhere. Oh, buddy, you haven't lived in America, have you? Ultimate bisexuality test. The ultimate bisexuality test is just Ryan Gosling walking into a room with any men on the inside. I think that's actually the test. I have a theory that there are certain people out there who like it's great. Who can test if someone is gay or bi. Because you show them a picture and based on the reaction you can tell if someone's gay or bi. There's different tastes.
What do you mean different tastes?
There is a different taste. There is a difference in taste between bi people and gay people. There really is.
Please elaborate.
I will in a second, but hold on, because Lemon said, make it, what's your opinion on large cooling systems? Because personally, I'm not a big fan. There is a difference in taste. There's a pretty big difference in taste, in fact.
Like,
Or maybe...
I know people of both categories, so but to be fair, I don't really know.
Consider the following.
Never
Fanboys.
thought of it actually. Yes.
That's a completely unrelated point. I just wanted you to consider for a second. But basically... it's just... I feel like Xavier X, you know, just controlling your mind. Consider the following. Fanboys, that's just me. Is liking fanboys gay? Actually, that was a question I've had for a really long time. I still have it, in fact.
I mean,
What do
they
you
are
think, Timon?
boys. Like,
Yeah,
they are
but-
boys, so...
Yeah. But
Yeah.
the thing is, the pickle there is that if you have a fanboy, if a fanboy is mistaken for being a woman, right? Then if someone is attracted to them, then that would probably mean they are straight, correct? They're attracted
Yeah.
to someone that they think is a woman. However,
You're alright.
just because they know it's not a woman, nothing changed. Besides the fact that they know that it's not a woman, all of a sudden that makes them gay. Which is interesting because in that case you have a person and nothing about the situation other than not even the identity, only the identity they think other people have changes their sexuality. Isn't that odd?
Yeah, I mean, androgynous people are always kind of like
Yeah, you have
androgynous
two
people can
clones,
feel
which
like
are
them.
you have two perfect clones, except one of them is a woman, one of them is a man. They look identical. And attraction to one person for a man would mean them being straight, the other would mean they're gay. And that's the pickle, that's the fanboy dilemma. I think honestly, with public research, I think this is where we should be pouring our money to figure this out. Make it, there is no pickle, that's called a penis.
Mark asked, "What if I like a Polish person? Then you're gay."
No,
That-
then I'm just sorry for you. Liking fanboy is only gay if you get to sex. I don't mean to go all sex ed on you, but it's actually not necessarily. Experimenting isn't gay unless you're over 30. I love the logical approach to fanboys. It's bugging me, okay? Because I think that, once again, my genuine belief is if you took an average, like if you took all people on Earth and took their average attraction, you would get a fanboy. Not a tomboy, mind you, as though tomboy would be the second one, but a fanboy. Simply because, make it. Can you answer my messages? I can see one of them. Oh, what did you say? I can see my pronouns are goodbye. I can see make it. What are you studying back there? And that's it. That's the only. I'm kind of worried. What other messages did you send? If you collapse the superposition of gender, it goes to either gay or straight. Exactly. You have a person, and there's basically a superposition of attraction. And the knowledge of their gender collapses that attraction. Which begs the question of, if you actually... Well, let's talk about sexual. Let's skip romantic attraction. Although romantic would be even easier, but let's just go for sexual attraction. If you do end up doing the YouTube demonetization with them and manage to skip over the realization, would that collapse the superposition? Because then you still wouldn't know, which means you could actually... Would that make you gay? Would that make you straight? That wouldn't be ace. Would that make you pan? That's a maybe. However, you yourself might have some, might feel, it's odd. Isn't it odd?
I mean, it's all odd because it's like trying to put very strict labels on something that is a mixture of many different things that range in many different scales. So
Okay, listen here, Taiwan, okay? Listen here, Batman. Girls kill the girls and no one bats an eye. But I cuddle with my homies goodnight. And society calls me gay. So listen, in my opinion, if we're gonna add labels, okay, then we better do it scientifically by the book. And if we're doing it, I am fine with having a complex theory of superposition of sexual attraction, okay? As long as it works. So being bi is the equivalent of superposition? Not quite, no. Being bi is the collapse to both sides. Superposition is the time of uncertainty. When you're attracted to someone without knowing, well, because you can be attracted to someone without knowing your attraction, without knowing the type of your attraction. That's the femboy dilemma. You're attracted to someone, but you don't know what kind it is. It could be heterosexual, it could be homosexual. You could be pan once again. However, because it would track with pan the most, in my opinion, right? You're attracted to someone, and basically you're attracted regardless of their gender, their sexuality, regardless of stuff, because it's just the attraction. And so the pickle there, though, is that I don't like the idea that everyone is pan until it collapses. It doesn't feel right. Because a lot of people are strong in their beliefs, right? Hello, Make It, how are you? Oh, paper, I'm fine, we're just talking about femboys, you know. Quantum sexuality, the study of uncertainty of a person's sexual orientation or superposition of it. Exactly. I don't know, but I think I have a preference for trying to do time, and I don't know why. That's a fine preference, I guess. Who am I to? I'm not gonna kink shame, unless being kink shamed is your kink, in which case your kink is disgusting. About being attracted
what
to...
did I read? I'm trying to find what you just read and I can't.
The Determinants comment is a bunch, honestly.
Whose comment did you read? I'm trying to find it.
Oh, I've just read 3. You have to be a bit more specific in that. You must teach me quantum chemistry. Pickle, we're doing quantum sexuality here. Oh, there's the... You see, that's the pickle there. That's the pickle right there. Now, what about being attracted to tom girls? Would the logic there reverse femboys? It would be. I'm so glad you brought it up. However, I don't know if you noticed, but it's always femboys. That's a curious thing. There is some asymmetry going on there. I think that the reason is toxic masculinity, if I'm being completely honest, but there is some asymmetry going on over there.
I'm pretty sure the same applies to tomboys as well. Like,
they make it. Hi, the hamster. Hi. We're discussing real societal problems here.
okay, but that was the previous topic of you telling me what is the difference between the preference of gay and bi people.
Oh yeah, right. So going back to it, when you have a femboy, correct?
Yes.
You will have situations in which gay people. So if it's basically the reversal. It's the reverse of what I mean. If you're bi and you see someone you're attracted to, you may not actually care. Well, I guess that would make you pan. Doesn't matter. The point is that if you see someone you're attracted to and they turn out to be of different sex than you expected, as a bi person, you're fine with that. As a gay person, not quite. That is the difference. Despite... So it's... If you have someone, so even if you, and that goes the other way, if you have someone who is of the sex of the gender that you would prefer, however, you don't realize they're of that, then you will not be attracted to them, even though they would fill in to your preferences. And with bi, it's different. Because well, you know, even if doesn't matter if they're a man or a woman, because you're bi, you're the two. I do still believe that bi people are cowards who just are scared to admit they're pan, but that's a whole different. And you see,
but people can have preferences, or they might like different things in different people, while pan people are completely blind to this kind of
yes,
thing.
but my point is that just the revelation will most likely not change your mind.
Yeah, but where you started your
Okay, you remember that
argument-
comment, that suddenly straight comment? A
Yes.
gay guy, you know,
Yeah.
kissing a lesbian because he thought that she was a twink and she thought that he was a lesbian. Like, that is an
Yes.
example of a gay realization which pushed them away. If, however, they were bi, it would be misunderstanding, but it wouldn't necessarily mean they would push each other away. Because right here, they necessarily must have pushed each other away.
Yes.
And that's my point. There is a difference there.
Yeah, but when you started this, you started talking about people just like if you walk into a room and show pictures, show a picture of someone to a bunch of people, you can figure
Yes,
out their
a fanboy.
if they're gay.
Exactly. Because when you have a fanboy, if you show a picture, right, then people who normally, or actually no, in this case no, the fanboy doesn't, we need to generalize a bit. Let's do it scientific general. Let's do an anti-symmetric identity person. Like in mathematics, you have the
mean an
identity.
You mean an androgynous person?
No, not quite, because in this case, you know the concept of identity in mathematics? You apply some
yes.
operation on the identity, you get back the same identity.
Yes.
It doesn't change the thing. Right.
Yes.
So in this case, it will be the anti-symmetric, which means that everyone who sees them thinks of them as the opposite of the way they actually identify.
Mm-hmm.
And the point here, if you show that kind of anti-symmetric identity to someone, then gay people will necessarily reject them if they shouldn't have, and will necessarily not reject them when they should have, whilst the bi people will not necessarily do that. And that is the test. We just need more like we need more mathematical approach to this.
Okay, but how would you actually do it in an as a experiment or as a field test of this? Objection?
2 steps. The first one is showing, because you can't do it with only one picture. That could be a fluke. You need multiple pictures, multiple people. You need you need a mix. So anti-symmetric identity is symmetric identity. You need both. Replacing every hold up or pause with C's. We're going to get back to revolutionizing papers later on. So hear me out, okay? You have a set of pictures. Actually, no. What should we call it? A better name. Let's call it we're going to have the false positives and the positives. False positive being obviously the ones that people misunderstand, positives being the one they took a fair point. So you have a set of pictures, right? For example, set of pictures of femboys and women. You show them to people, you show them to men, right?
Yeah.
Then all of them decide if they are attracted to them. Actually, no, that would be for straight people. Actually, it works also with straight people. Doesn't now only have to work with. Actually, yeah, fine, whatever. You show them to a group of straight men, and then if some of them, after learning that the person was of different sex than they previously thought, if they still hold the same opinion, no one gets straight.
The only problem with this
Because
is
it
that
collapses.
like for this to work, you require you require honesty from the test
Participants.
subjects.
Yeah.
And if
Something
you
in mind. I went with participants. You went with the subjects. Okay, carry on. Well, yeah, you require honesty, but you know the whole point of the test is to figure this out, right?
yeah, but if you require honesty, then you can just ask them that, hey, what's your sexuality? Like, it's
Yeah,
not,
but they might not know. That the whole point of the test is to help everyone figure out. That's
well, you can figure it out. Like, what?
no, because a lot of people don't. A lot of time people don't know.
I know, but like you can figure out your sexuality like this.
Well, I mean, I'm just saying that it's an efficient way to do it. I feel like it. So what? Okay, so here's the thing. Okay, we right now have like billions of people or millions of people entering societies without ever being subjected to a test of sexuality. Don't you think that's like social education 101? Like with I don't know, when with asking people when to pick their career paths, and so then when they are adults they already know what career they want to go for. Then when I say adults I mean like 25, 26, right? When they're adults they know what career they want to go for because they've previously been shown the options, but they don't know what sexuality they are.
Yeah, I mean that's a common thing. Yeah.
How can you be up for so long? I genuinely get tired. I am just passionate about science. Hi there, Farmer Main. Welcome. You've joined in at the perfect time. As there's just a lot of stupid discourse, people getting mad at each other for erasing bisexuality or transphobia. Wait, what does erasing bisexuality mean?
It's basically just not acknowledging it, and if someone is bisexual, they try to force them into gay or straight boxes.
What? I mean, I feel like there's an easy way to silence the critics there. Fuck both their parents. I mean, try to not acknowledge them now. Pretty simple solution. I mean, am I wrong?
You're absolutely right.
Exactly, yeah, there we go. for more solutions to problems, join in next week for another segment. Okay. I have nothing better to argue and bring down the community, so focusing on the actual truth of the community. I'll tell you. As much as I like, as much as I like gay memes, one thing I really don't like about gay memes is when they just do stereotypes of themselves.
Oh,
like,
that's so bad.
Like
That's
I don't
so
know,
bad.
you know, oh, straight people carry groceries one item at a time, whilst gay people carry them all. No, they don't. No, they don't. Just give me the funny mics from Breaking Bad saying you are not the guy. Those memes, those are funny.
Yeah, like I don't know how is it today because I don't really yeah, but one time I think I looked at r/slash bisexuality for or r/bi I don't even know, like something like that, just out of curiosity, and it was just stereotypes. Like, the entire subreddit was just by people putting stereotypes on themselves, and
It's
yeah.
annoying. It's just annoying. Stupid bi versus pan discourse. Let me stop right there. Because as I mentioned, bi people are just cowards who are scared to admit they're pan. So before you go on, my hottest thing, I don't know why I stuck to this bit, but I mean, actual biphobia. I've never heard of biphobia. I mean, homophobia, I've seen that a lot. I fucking live in Eastern Europe. but biphobia, not really.
It's very very strong. Like even within the LGBT community, it's there. It's like, for example, like there are even gay people who just refuse to acknowledge bi people because they feel like they're, I don't know, traitors for liking the opposite sex. Or I don't know.
Queer spaces online are so fucking toxic. You mean like random groups of people online actually end up being toxic to each other simply because they're brought together by a vague concept that actually brings together a swath of groups of people who actually have nothing to do with each other, other than like something that doesn't actually define their personality in any way. That must be a shocker. The thing is, when it comes to online communities, is that you should have online communities based on something common. And when I say something common, I mean, because everything can be common. What I mean is common thing that can bring together people with like that like similar stuff, people who believe similar stuff, people who have similar personalities, stuff like these. That makes a nice community. The problem is that there is nothing like defining what gay people like. There's nothing. Gay people don't have the same personality, or it's
Don't
just
they like gay people?
a bunch of different things. And so, yeah. Wait, would you say it?
Don't they like gay people?
Well, I mean, yeah, but that's not defining their personality, is it?
Also, I know a lot of gay boys who are especially attracted to straight boys because I don't know, they talk about them being more masculine or whatever, which is like sounds like a major skill issue. I don't know.
I do
what
have to say
but-
that that's actually kind of off-putting. You just say gay boys liking straight boys.
Yeah, like that's how they put it. Like they are.
That's a bit off-putting because I mean that goes both ways, and when you see it from the other way, you see because that's kind of like, I don't know, straight men liking lesbians. I mean,
Yeah,
it
that's
doesn't.
like it's not like it's not that they say it like they like explicitly
Preach, mate, preach.
it's like they like boys who have more straight-ish personality, and that's why often end up falling for straight guys instead of falling for gay guys, and which is a struggle.
Look for bi men. Look for bi men. My goodness, simple solution. Jeez, that's it. Bi walks for both. We are in short supply of bi people, I do have to say. I feel like 90%, 97% of our societal problems could be solved if we just had more bi people going around. If gay means happy, pi means food, and bi means bipedal, then I am straight, unhappy, hungry, and physically disabled.
I mean, it's like 90% of bi men are just in the closet because yeah.
And that's why we need the test. That's why we need it. 1984 mandatory sexuality tests. In the Make It government, every single person, the moment they turn 22, because I feel like that's a fair age, the moment they turn 22, they need to have sex with every single, like, we need to make like a mathematical system where people will statistically have sex with every single sexuality just to make sure, just to make sure to figure this out, you know?
No, but for it to work, people also must have sex with every single gender.
No.
All of them.
We can create like a mathematical system. No, so like thermodynamics, except for sexualities.
But having sex with someone with a certain sexuality does not tell you anything about your sexuality. Like the only
So a straight man has to have sex with another straight man.
We don't know if they're straight. Listen, the wave function of sexuality hasn't collapsed yet.
that's
You
why
need to measure it.
Yeah, but because
You
don't
can't
know
tell where
that-
the particle is until you've measured it. How are you supposed to, like, tell me, Iti, let me ask you a question. Have you ever eaten fucking, and I'm trying to come up with some really fancy food, but have you ever eaten caviar?
I think so. Yes.
Damn it! I can't think of any fancy food that because I'm
Yeah.
not. Have you ever eaten
I-
shark?
Shark. I don't remember. Might be in Thailand.
Okay, so do you think you would like shark meat?
Probably.
Yeah, you have a guess,
Because,
but you don't actually know.
I do. I think I ate it, so that's why I say probably.
Okay, whale. I'm gonna just keep going until I find one. Have you ever eaten whale?
Not well.
Yeah, okay, that
So,
makes sense.
the-
Do you
have-
think you would like whale?
Yes.
Why?
100%. Probably because it doesn't differ much from a whale, from a shark. And
Actually-
I think I might have eaten other whale products or something similar to whales.
Like,
they're
what
like
could you
monsters.
what could you fucking eat that was similar to a whale? I'm sorry. I know we're getting on a tangent, but I
No,
want to know
I've
now.
eaten a decent amount of seafood.
Yeah, but here's the thing, E.T. Haha. You fallen right into my trap. You see, fish aren't actually that genetically similar to a whale. So right now you think that you would like whale because you associate it with a different food that you think is similar, when in reality it's not actually similar. And because of that, that's basically your taste buds not having the wave function collapsed for you to actually figure this out. And so right now you might be living in the misconception, whale could be tasting like shit, and yet you think it would maybe taste nice. You see my point?
I want to eat whale.
I feel like J-Reg. I do have to say, I don't know how many people watching here know J-Reg, but I now know how J-Reg feels every single time he makes one of these bad shit, insane arguments.
I love how you just want it to be a legal stuff to everyone to have mandatory sex with every identity.
I mean, then it
and,
wouldn't be illegal,
you-
would it? Because the whole point is that, you know, when we take over all the governments of the entire world, then we'd have mandatory sex at 22.
and you expect us to believe that this is not a projection of your desires.
Wait, what did you just say? I was busy reading. What did you just say? Hold on, because it hit me after a second. Make it don't apply mandatory sex or to asexuals. I mean, yeah, there certainly are some ethical questions there, believe it or not. There are some ethical questions. uh. You won't believe, but there are some ethical questions attached to that. So, okay, but unfortunately, our other policies of subsidized weed for scientists, those still apply. No. Schrodinger's gay cat. That's exactly what it is. Every single person has a different sigma function of their sexuality, and this hasn't collapsed. And actually, I don't think it even can collapse. In my opinion, it's a different kind of function. It's a function of uncertainty, where where you don't actually know the shape of the function. Only different measurements give you different values, so you can approximate it with a polynomial. But I don't think you would actually be able to get the full function. At no point. Not gonna lie, most people are straight more or less. How would you know, Sadness? How would you know? Those most
more or less,
people
like-
that you talk about have never had gay sex.
Like more or less, like less is an option. So
Also, the fanboy test. Let's get back to the fanboy test. What about that? What about all the men, in quotes, straight, who are still attracted to fanboys without them knowing that they're fanboys? And all of a sudden, knowledge of the fact they're fanboys? Okay, how do you account for that? Because for some of them, yeah, that may be their sexuality. But for all of them, how do you account for social pressure? What about that? Huh? What about social pressure? What about they say that they don't like fanboys simply because of social pressure? What about those?
I mean, if you wanna cut the stream short to look up the pictures of fanboys,
Oh, don't worry. I have like a third monitor screen just for that. Actually, just don't worry. It's my research on the
Alright.
topic. Oh, I've researched many fanboys. I know them inside and out. Honestly, like, I know I have deep connections with a lot of them. Okay.
Where is make shit in the time of need?
Make it very safe for research. What do you mean? You mean, hold on. You mean the video game? that's for other kind of research. Forcing people to sex is dystopian. What part of that is dystopian? Oh my gosh, when the flame joins in, it's gonna be mad explaining, like, we've gone on a bit of a tangent.
It's for science.
It's for science. That's exactly it. There might be some ethical questions attached. Oh. But yeah, exactly.
Alright, if someone has all the options in front of them, and also one of the option is like, you know, all the options like okay, so the ethical.
Oh my goodness, hold on. We haven't even touched on the topic of sexual attraction versus romantic attraction. We haven't even accounted that into our model. Oh, that's such a massive part as well. Actually, what if there are more than 2 types of attraction?
There are 7.
7? Oh yeah, I'm not familiar with the new models. I've been too much into physics, too little into sex, you know.
Not that a new model. That, like, it's quite an old model in psychology. Like, that's sexual, romantic, aesthetic, platonic, emotional.
Wait, then why are we using an old model?
I don't know the last
We need
two.
to change it.
I
I don't trust old psychology models because they were kind of they were
not
kind
that
of
old. It's not that old.
This isn't even funny, not gonna lie. Literally 1984, you must have sex. What part of that is 1984? I don't trust all psychology models because I very much do not want to fuck my mother. What do you mean? Give that guy Freud a chance, you know? Maybe. What do you mean Freud had mommy issues? No, he was just good at psychology. You just don't understand it. I can say something insane right now, but Borsid, you can make it to ban me. Ashad, I just said about mandatory sex. I've just proposed the concept of mandatory sex. Like, where is your bar?
Oh, intellectual was the last one that I forget. Intellectual and sensual. Yeah, those are the last two that I
Hey, what's the
forget.
name of the model? Because I just want to look it up myself.
Just 7 types of attraction.
Yeah, right.
This model, it's
7 still feels low. 7 as attraction, okay.
7 feels like a magic number. Like,
Yeah.
I don't know, I like this model because it's
I don't like it because I'm getting a bunch of clickbait articles. Is there a different name than 7 types of attraction?
I'm gonna look it up tomorrow.
Because one of the websites is called the Dreamcatcher, so I'm kind of, and the other one is Reddit.
All right, that's fair.
Then you have Soulmate, that's a good one. Conscious Rethink, solid. Haunt Society, that's good. There's a lot of quizzes to figure out what kind of attraction you're feeling, which is solid. Would a quiz the BetterHelp? Oh, they're doing great work. They haven't had any controversies recently. That's good. More quizzes. You've also Reddit, TikTok. Oh, there's that sort of thing. Well, Attraction Diary. They would at least have it in their name. I suppose they would know something. Tourist teacher is giving 21. Oh no, that's tourist attractions. Never mind. That makes sense then. Okay, that's a different kind. Yeah.
The only reason I like it was because it shuts those up who think that there are less of them. Like it sounds like a valid psychological model because not too low a number, not too big number, and it shuts up those who try to claim that sexual, romantic, and aesthetic are and platonic are the same, and because like what? No.
Then there's also the
So, yeah.
make it attraction, but that's a fundamental force. So, precisely. How did everybody in urban areas not just reek like stale shit all day in colonial times? Who said they didn't? I think sadness is right there. Make it, have you been offered any sponsors? Considering the conversation we've been having so far on stream, are you surprised?
I mean, I could see Bad Dragon sponsoring you.
No one leave because the conversation is so funny. I have that effect on people. They just want to piss when they're around me. Make it, what attraction do I feel when I see the borders of the Holy Roman Empire? It's... I had a joke there, but it just vanished the second I thought of it. Damn it. Just pretend I said something funny. Grind the sponsor coming up for Make It. No, I can't do a grind the sponsor. Because that would like... That's what I'm saying. Okay, with sexuality, I think that the best model is not quite a complete collapse of the wave function. It's a partial collapse. So basically, hear me out. You have some kind of function, right? That you don't know about it. And then every single time you do a measurement for each x coordinate of that measurement, obviously it will be higher dimensional than just 2. But for each x coordinate of dimension of the function, right, the input, for every single input, which would be like the different properties of the person, hope, fingers crossed, person that you had the relationship with, you would get the value of attraction, right? And the point is that it would be, and then you would approximate it with a polynomial. And each additional data point gives you a better approximation of what the polynomial would be. And so in that case, I actually can't have a grinder sponsorship, unfortunately, because so far for my wave function, we don't know it. Actually, sex function, let's call it a sex function, let's be real. So for my sex function, we don't actually know anything. We don't have any data points. What attraction do I feel when I hear the word freedom, foot fetish? What's the real value from finding this polynomial? Haha, you can make better predictions. That's why we do science in the first place. In this case, if you find the polynomial, then you can figure out better. You can figure out the see the point.
What do you mean? What do you mean your function has no data points?
Well, I mean, what's my sexuality then?
I mean, but you like.
What sexual attraction?
You said you know it, so you must have some data points.
Have a solid guess. Yeah, I mean, I guess you don't need to have sex with people to still get the value of attraction.
Yeah, exactly.
However, for all you know, but no, my point is I can't have a grind sponsorship because then I would give you the data, and I like keeping you in the dark. It's kind of my kink.
Yeah, but like just because you do that sponsorship, you don't give us any data.
No, I mean, as long as we grind it, everyone would think I'm gay.
They already do.
I know, that's the joke. The make it sex function better than Riemann zeta function.
Okay, that's a very high ranking.
Okay, but money.
That's a compliment.
I don't do sponsorship for money. If I'm gonna do a sponsorship for Grindr, it's because I believe in it. We had satis function, now we have the gay function. No, actually, I guess based on the definition, you could call this the satis function. No, but it's the sex function. I like it. For every non-trivial sex that make it has, there will be a zero. There will be a zero. This is actually great.
I have to ask,
Yeah.
how did this stream go from we're done about ranting about moles to working on a video?
Oh, that's simple. I started researching maths, and this is just mathematics when you boil it down, right? The sex function. This is just information theory or something, you know, just basic stuff. What's more? What's more? For every single data point like this, you could figure out the slope. Hear me out. If you see a person, if you think to yourself, what would make me more attracted to them? That is the slope of the sex function. Because you know which properties you want more, which properties you want less in that specific point. What would the slope signify? That would be obviously how much different changes. So for example, if you, right, as a person, if you really like, because in this case, this will be a multi-dimensional function and a lot of dimensions, you know, you need a lot of dimensions to describe a person. But if you really like, I don't know, dominant women and submissive women, but don't like what's in between, then this gives you the slope of your sexual attraction based on dominance at any point. So the slope in this case would change over the course of this because it's going down and up. And the slope is basically how much at that point the change in properties, whatever, let's call it properties, the change in properties would affect it. What's happening? I just joined in. Oh my god, I'm not going to explain. This is too much, okay? We're talking about the sex function. That's all I'm going to give you.
People can take you out of context so much in this stream.
I mean, I feel like taking me in context would be more funny than taking me out of context at this point, to be honest.
So, I just want to ask, what does non-trivial sex mean? Like,
Oh, that's when, because trivial sex is when you have sex that doesn't give you any more information.
Ah.
Yeah, exactly, you know, it's non-trivial sex, yeah. This is one of my favorite live streams I had in a while, I do have to say. But yeah, basically, and then we could do an even better model, because not only, because we can upgrade our polynomial. Normally, when you have points, you can do the polynomial. I would need to ask Reblax this, you know. Oh, actually, Lemon, as our right here, our sex mathematician here. Would you mind helping you have this? If I have a bunch of points, right, in an n-dimensional function, we don't know how many dimensions, and I know not only all of their coordinates, but also the slope of the function at that point, is there a better way to approximate the function than with a polynomial? Actually, could you even wait? Hold on. Could you even describe it with a polynomial if it's n-dimensional? This is tricky. Resident sex. Quantifying sexuality sounds wrong, because where's the fun in suspense? The fun in suspense is that I'm pretty certain you will, well, actually not pretty certain, I'm certain that you will not be able to describe the full function unless you have an infinite amount of data points. Which means that unless you sex for infinity, you will not know your function perfectly. Therefore, every single sex you have increases the certainty or decreases the uncertainty.
Are you sure about that?
Yes, because when you have a completely arbitrary function, it doesn't even have to be continuous. That's the thing. It doesn't even have to be continuous. So when you have a completely arbitrary function, you do need an infinite amount of data points to specify it. So if I just give you a function f of x, if I only let you like measure that specific points, you would need an infinite amount of points to figure out what the function is.
Okay, but how do you determine how, okay, you have one, like, you have a night, but how do you determine what made that night fun? Like, The person.
Well, that's the
Who's
properties,
person?
you
What-
see. That's why our function is n-dimensional. Because this kind of ties in together with the Sanders question. What if you have contradictory sex? I'm assuming what you mean is that by contradictory sex is sex with the same property but different results. Obviously, functions cannot take in the same coordinate, give you two different results, unless there's an additional coordinate. So basically, f of x is equal to 7, and f of x is equal to 5, that's incorrect, because it's giving you the same thing, different thing at two different places. However, f of x and 2 is equal to 7, and f of x and 3 is equal to 5, that is correct. Then it's fine. Which means that, oh, higher flame, wow, hi, listen, I kind of got... Hi, Flame. So I was kind of waiting for you to join in and went on a bit of a tangent. Yeah, I don't exactly know how to explain where we've been. It's kind of a long story. It started with determinants in the matrix determinants, then we kind of created a mathematical theory of sex. So
Make it. Are you sure this doesn't go against any of the guidelines in your own YouTube?
oh, it's as if I care about those silly words, right? Just come on.
No, if
Those
you
were
want to stay monetized, you should.
oh, they don't mind. Those things. Come on. These words there, they're just like for the funsies, for fun. They're just goofing around, ironic. They don't mind, I'm certain. In one of the live streams, I just used a prop gun as a joke, and they didn't mind. So I'm hoping they don't mind me talking about sex. Reblax! Oh my goodness! What the function is going on here? Oh, Reblax, I am so glad you asked. Let me know when to join. Just spend the full 90 minutes reading just a bit. Oh, join in right now, because you don't want me to go on even more. I feel like I've exhausted the topic. And so this concludes, everyone. This concludes my TED Talk, my sex talk, my TED Talk, I mean. And I will, and next time, in the next episode, we'll talk more about the sigma sex function. We'll talk about more next time. For now, you all, for your homework, need to give me some data points.
Yeah, I mean, I still have a question, but I think I can let. I think that can wait until next stream.
Oh, I
But
see.
I still have a question.
What is the question?
so-
Go ahead. Just for me to prepare for the next live stream. Prepare my theory more in depth. What is the question?
All right. Is that okay? You know that you have a lot of inputs, but you have one output, like an enjoyment. That's one output. And how do
Yes.
you know how much the
Great
data-
question, Timon. Hold on, let me first look up sigma, because apparently I think I wrote it backwards. Lowercase. Okay, yes, it's this way. All right. So, great question. You can do it by defining multiple sigma functions. And then for every single interaction you have, because in that case, it's very more general, you can fill in the functions for different sigmas. Now, the question is of whenever there is some sort of relation going on between them, for example, so you have, for example, sexual sigma, you have romantic sigma, you have platonic sigma, all of these. The question between them is if there maybe exists an operator, some sort of lambda operator SR, for example, which when operated on the sigma function, that's kind of a 6, which operated on the sigma function will give you a romantic function, right? There exists a question there, which if a theory was to be completed, then for every single person, you would be able to, just by filling in the data for one function, you could maybe fill in data for the other functions. But that obviously requires answering the question of what is the lambda sex to romantic operator, which...
agent value and the agent vector.
Yeah, you can get the eigensex vector.
Eigenstate problem. Yeah, all right.
Yeah, exactly.
Okay,
it's
this
the-
makes more
yeah, yeah.
sense.
It's the
This is
eigen.
quantum sex.
Well, it's the
Exactly.
sex function. We're trying to solve sex, basically. You know. Hi there, Flame. How you doing?
Hi.
How's your day going? I got
Yeah, it's
kind
been
of.
a very long day.
Yeah, I mean, I can tell. I mean, you basically asked me. By the way, you've asked me however many days ago if 24. So 3 days ago, you asked me if
It was just Friday, yeah.
yeah, and then on a Sunday, I realized, oh my goodness, you asked me if to join the stream on the weekend. Uh-oh.
No, I've been very busy anyway. There's so many things right now.
I mean,
It's like
yeah.
I've got my presentation tomorrow, and I've got a bunch of inorganic chemistry questions, and I've got my research report.
When does all due, by the way? Like all of your
Well,
work
the
and stuff?
presentation's tomorrow. The
Yeah.
inorganic was due on Friday, but I got
Oh.
that extended by a week. So that's due on this Friday. And the report was due this Friday, but that's extended by a week as well. So next Friday.
Would you be free in a week and a half? Or free-ish?
I'm free after the 7th.
Okay, that's good enough for me. Because remember back in the day when you know, back in the day, remember when a while back ago I approached the idea of, you know, doing the video in a day.
Yeah.
Yeah, I just feel like still think it'd be a fun idea.
Yeah. It's only it was gonna be done by 1st of February, and then now I've extended it by a week, so extra week.
It's always funny how how I really often hear it like, oh, when is this due? Oh, it was due like last Friday. Yeah.
Yeah. It's so many things.
Okay, but you have a presentation. So, Flame, you've prepared a
Yeah.
presentation for us, I understand.
Well, it's not for you,
I know.
but I'm gonna yeah, I'm gonna present it to you. Which means it will probably take longer than it's meant to, because I'm gonna like explain things a bit more clearly.
That makes sense, but
Right, because like when I'm giving this tomorrow, it's to a room of chemists and biochemists, and so I don't need to explain like what a cysteine is or something.
I was praying so hard that if you give an example that I would be, but I don't know what cysteine is either. So okay, that's good. All right,
Well, I can show you what cysteine is. Hang on.
I'll try my best
Here
to
is
ask
your-
good follow-up questions.
That's cysteine. It's an amino acid. Wait, do you know about proteins and amino acids?
Yeah.
Okay. Well, cysteine is an amino acid.
Okay, in that case, all right, that makes sense then. Now but that explains why I don't know about it, because my body just rejects remembering any kind of molecule. It's just
Okay,
It's a
well that is
medical
not great
condition.
for like all of biology. But
no, it's fine. This just doesn't matter. Like proteins, you don't need to remember everything about them, do you? Just like they're folding chairs, basically. That's it. So you need to remember proteins.
yeah, sure, yeah, sure. Let me see if I can get this up. Let me check I'm not doxing.
This can be fair. Reblax, you said, I mean, mathematicians have never been able to mathematically model sex for obvious reasons. What do you mean? You literally have game theory, okay? I mean, come on. Wait a minute, some researchers just think that sexuality changes over the course of a lifetime. How did you account for that? That's simple. Add another, that would be the part of the n-dimensional function. Like, one of the inputs would have to be obviously time. That's like one of the more obvious inputs. The location is also there, right? Context would be hard to quantify, but it's doable.
Okay, if I do this and then click present, does it break? What does this look like to you?
It looks there, that you can see it on the stream.
Well, I can't because it's popped up on both of my screens.
Oh, I see. Well, looks
it's
like
on the PowerPoint thing.
yeah, it looks like PowerPoint. You can see the presentation and you can see the PowerPoint.
What? Can you see this like note stuff on the side and like next slide and all that?
Yes. Well, I mean, I can see.
Let me just look at the stream because there's a delay. Hang on.
We have.
Oh, it doesn't even present for you. That is weird. Okay. Oh, maybe it presents it in a different window. That might make sense. How can I? Display settings. It's not in display settings. Oh, what has that done? That is broken. That's just turned off a monitor. Okay.
They'll say we have game theory but no game practice. Just
high presenter view. Okay. Now if I screen share this.
Yeah, that's full screen.
Does that work?
Full screen presentation. So may I show it just to make sure that's the right?
One sec. Let me just. Yeah, that's all right.
Okay then.
Okay. You good?
Yep.
Okay, so what do you know about this already from like what I've told or shown you?
Spectrometry.
Just the topic. Spectrometry. Yeah. That's
that's solid. I know mass. I know what mass is.
You do know what mass is. That is very helpful. Degradation
of protein-bound iron sulfur clusters. I mean, I get what that combination of words mean. It's how protein-bound iron sulfur clusters degrade. That's so. I'm assuming iron sulfur clusters which are bound by protein and how they degrade. I'm practically a chemist, so you know.
Yeah, good enough. So, so I'm going to talk about, essentially I was given a prompt, which was how do you follow degradation of protein-bound iron-sulfur clusters? And I knew about mass spec, I knew a bit about protein mass spec, but I didn't really know about this, so I had to go and do a bunch of research for it. Thankfully, it was in literally like 3 of my lectures, so I kind of cheated, but it's fine. Anyway, so iron sulfur clusters. These are, surprisingly enough, clusters of iron and sulfur atoms. Amazing, right? And the way these work, I've drawn the irons are in red, the sulfurs are in yellow here. They can be found kind of inorganically. You can make them as just clusters, like in molecules. But generally in biology, they're found in proteins and they're bound by certain amino acids on the protein. So usually that's a cysteine, which is like a small molecule chain bit that has a sulfur sticking out. So that sulfur can then stick to an iron. So in this case, we call this... can you see my mouse?
I know.
Let me get the pointer up. So cysteine, essentially, we've got iron, sulfur, and I haven't drawn the rest of this, but the rest of this would be like attached to a protein. This is a carbon. Cysteine is like a small organic bit with a sulfur sticking out, and the sulfur holds our iron. The ions are always tetrahedral, which means they're bonded to 4 things. You can kind of see the shape here, where it's like you got 2 here, and then these 2 are in a different plane. Same for all of these. But yeah, this first one basically isn't really a cluster because it's just an ion that's being held by 4 cysteines, and the others are clusters because you can see here 2 ions, 2 sulfurs. We call it 2 iron, 2 sulfur. 3 iron, 4 sulfur, 4 iron, 4 sulfur. There are higher ones, but they tend to just not be relevant. Like these are the main ones. And the cool thing about these is they can degrade into each other, as we'll see later.
That makes sense.
So, to go into a tiny bit of inorganic hell. These are diagrams that are kind of familiar to chemists, probably not familiar to biochemists, but essentially.
Good, bringing the theoretical to biochemist. Good, you're doing good work.
I know. In the thing, like this morning, I did a practice session with them, and they looked at this slide and they freaked out. They were like, "Why are you talking about it?" But essentially, what this is each of these white lines is an orbital, and as you know, an orbital can hold 2 electrons.
Yep.
And so when we have iron 2, iron usually starts with 6 d electrons. Not 6, 8 d electrons. And when it's iron 2, that means you've taken 2 electrons off because it's 2 plus. And so here you have 6 electrons. And so you fill these up with 6 electrons. And in this case, sulfur ligands, when we say ligand, it means something like attached to a metal. They create a kind of small gap between this upper and this lower one, which means that as you fill these up, you kind of fill them all up one by one, and then you go back and fill this. Whereas if it was a much bigger gap, you would fill up all the bottom ones first, and then move on to the higher ones. And so that would affect the spin, because if you can imagine, if these were filled up first, then you'd have an up and a down here, and an up and a down here, and then only 2 ups here. And so that would be a whole spin of just 1, right?
Yeah.
Because it's half plus half, and then these cancel out. And it's just the same, but with iron 3 plus.
1 less electron, of course.
Yeah, 1 less electron, and so this is slightly higher spin. And this delta tet just means it's a tetrahedral field of ligands, which is causing the splitting. Because, usually the d orbitals are all the same energy, but in the presence of the sulfur ligands, due to the geometry, I can show you this later. I might have shown you it before. It essentially pushes some of them higher in energy and some lower in energy. It splits the energy levels. And with octahedral, this is like the other way around, with 2 on top and 3 on the bottom. But yeah. So when we do this, we get high spin ion centers, which is that thing I told you about, the gap here, where if this was higher, it would be low spin. But the thing is, these ions inside the cluster couple to each other antiferromagnetically, which is a big word. It basically just means you subtract the spins from each other instead of adding them together. So ferromagnetic coupling is like adding the spins, and antiferromagnetic is subtracting them. And so what that means is it produces a bunch of different energy levels, but the lowest one is the lowest spin. So you can see here it's spin half in this case, which means that, if you freeze it, it's only going to be spin half. As you heat it up, it spreads more evenly throughout all these energy levels, but generally it's going to be sitting in, the lower spin areas.
Yeah,
Yeah. This is just an example. There are also like different clusters that have multiple, like, for example, a 4 iron 4 sulfur cluster will have like a bunch of these and not just.
So, hold on, am I understanding correctly? So, if basically when you're in a cluster, this is because they couple antiferromagnetically, but what couples antiferromagnetically is the ions.
It's so the spins of the ions are interacting with each other.
So if you had the high delta the tetrahedral, was it?
Yeah. Okay.
If you have it high, then the coupling between them is going to get weaker.
You would have. I don't think the coupling would change. It would change the numbers you get here, because this S would be 1 and this S would be.
So they get smaller, but both of them get smaller. So, and both since you subtract them, then it doesn't matter.
Yeah.
Okay.
But yeah, and this is a lot of theory. I kind of only go into this because I like it. But essentially, the main takeaway is that they do a bunch of funky stuff with their electrons, and that is really useful for their functions. So, one of the main things that these will do in proteins is transfer electrons around, because you can add an electron to change the oxidation state of one of the ions, or remove an electron. In the case of this 2 iron 2 sulfur one, you can kind of go back and forth, but in like a 4 iron 4 sulfur, you can do it successively, kind of multiple times, because you got more ions to reduce and oxidize. And so this is really useful in biology because you get to move electrons around, which is super important for like
Kind of a
everything.
big deal.
So like photosynthesis, respiration, pretty much everything. And you also get catalysis applications. I think you know what catalysis is, which is like you're just reducing the energy barrier for certain things to happen. In this case, it's mostly because of their kind of electron stuff. But there are also cases of some proteins where like the structural changes in the cluster will affect how the protein behaves, which catalyzes something else. And I think these can also catalyze like radical generation. I don't know how much you know about radicals, but they're useful in biology. One of the main things I'll be looking at is the sensing of small molecules, because these things interact with stuff like oxygen molecules and nitric oxide, which is NO, and they can also interact with like loose iron atoms. And so in the case of oxygen, we'll see later, these actually degrade when in the presence of oxygen. And they can also be used for gene function regulation, which I will talk about here. So I'm going to zoom in on like a specific example of a protein that uses these clusters. And in this case, it's called FNR, which stands for fumarate and nitrate reduction regulator, which is a very big biology name. Essentially what this does is this whole protein, so this is called a dimer, where it's like two of the same thing just stuck together. It's like two proteins that they like being together. This whole thing, it binds to DNA in a certain place, and the place where it binds is onto the bit that controls the gene for aerobic respiration. And so this suppresses aerobic respiration because this blocks that gene from being expressed on DNA. And so while this is around a cell, and I think these can be found in like E. coli is a really common one. Basically most bacteria. This just stops respiration, aerobic respiration, and so the cell would just be doing anaerobic. I don't know. Do you know about?
I was just about to ask what those are exactly.
Oh, okay. So aerobic respiration is what we do, where we breathe oxygen. It's essentially taking oxygen and using it for energy, whereas anaerobic respiration is stuff like like lactic acid buildup in your muscles when you're exercising. That's like when there's a lack of oxygen, but it still needs to do respiration. And so it's like producing energy through other means, which are kind of temporary until you can get oxygen again. So that's the main difference.
Wait, but it's present in the DNA.
So what this is the DNA is controlling what the cell does, and this is controlling which parts of the DNA can be read, because the DNA is like an instruction book, right, for the cell. And so this literally goes in and blocks the part that does aerobic respiration on the DNA. And so while this is on, the cell doesn't do aerobic respiration. But the thing is, our cluster here, in the presence of oxygen, breaks into a smaller cluster, and this breaking completely deactivates the protein. The protein breaks off into, instead of the two, it breaks off into individual proteins, and it unbinds from the DNA, which means that the DNA can then express that gene for the aerobic respiration, which essentially means that when oxygen is around, it does a bunch of steps, and then your DNA tells the cell, do aerobic respiration. Does that make sense?
I think so, yeah.
So just to reiterate, it's like oxygen comes in, this cluster
And that's
breaks
why
down.
detecting small molecules is important.
Yeah, so this is detecting oxygen and telling your cell to breathe.
Yeah, so basically this is like because we obviously prefer to breathe with oxygen than in any other way. And so however, if there is no oxygen, you don't want to breathe with oxygen because I mean you're gonna suffocate. And so this is basically like a detection system to let the cells know that, oh, we don't have any more oxygen, time to switch up to the less efficient forms.
This is the opposite one, where it's actually, oh, we do have oxygen, switch to breathing.
Oh yeah, I know.
normally.
I know. It's
yeah,
just like when
okay.
you no longer have oxygen, then
Yeah.
Then
There
you-
are other mechanisms for like.
and
for
okay, and
anaerobic,
so
yeah.
if you're breathing with your breathing, I can't remember the words. I mean, so if you're breathing with the less efficient method, and then oxygen comes around, then this will stop you from breathing with the less efficient and will actually
Yes.
make you breathe oxygen. That
Yeah.
makes sense. That makes a lot of sense.
I think the reason this is even needed is because if you're trying to do aerobic respiration without oxygen, it's just really inefficient, or it like causes problems or whatever. And so this is like this protein exists to like stop you from breathing when there's no oxygen, and then the cluster deactivates the protein when there is oxygen. And so when this cluster breaks down, it's not all in one step. It kind of goes through an intermediate where it's like a 3 iron 4 sulfur, and then it goes to this one. So it kind of just yeets away its ions and sulfurs. So I'm going to talk about mass spec. I don't know how much have I told you about mass spec?
Mass spectroscopy. I mean, you probably told me a lot. It's just that I don't associate like explanation with the names of them.
Okay.
So I probably know it. Here's
So
that.
so mass spec
Oh, is it separating them just by mass?
separates them by mass to charge ratio.
Yeah, then that's what you're doing. I know that really well, in fact. Okay.
Yes, yeah. So my research part of it is mass spec, a specific type of mass spec.
Apply electric field if electric field accelerates charge, however, which means that the things with higher charge will accelerate quicker, but at the same time, acceleration is inversely proportional to mass. So things when you apply a force, so things with higher mass will accelerate slower, and because of that, when you apply a field on something, then charge to mass ratio is what actually tells you how quickly it will go.
Yeah, exactly.
Yeah, then I know it.
Okay, well that's one type of mass spec. So, well, in order to separate things by mass to charge ratio, they need to actually be charged. In the
Makes
case of
sense.
my research, that's just plasma. But in the case of this, with proteins, it's quite easy to like break them apart. And if you try and do my like brute force zap it with electrons method, it doesn't really go well. It just breaks the proteins apart. So you need more gentle methods. So the example I've got in this picture is called electrospray ionization, where it applies. So you have your sample dissolved in a solution, and you apply a voltage. And so what this does is it accumulates positive charge over here, and makes it kind of evaporate, or not evaporate. It aerosolizes it through space, and as it travels, you evaporate off the solvent, so it just leaves your like positively charged molecules or proteins in this case, which will then go into the sample, into the spectrometer. Does that make sense?
I think so, yeah.
So yeah, you get them to kind of eject out through the charge thing, which also charges the thing, and then you evaporate off the solvent to just molecules. There are also a bunch of others, like MALDI stands for matrix assisted laser desorption ionization or something, a whole like complex name where it's basically you just shoot a laser at it, and it's next to
Wait, if you shoot the laser at it, what's the difference between this and photoionization?
very different. This is okay. Photoionization is similar, but this the matrix thing is like a material that it's combined with, like in a mixture, which can absorb the laser energy really efficiently.
Oh, makes sense. Okay.
And so it's mixed in with something that absorbs the laser energy. Then you shoot the laser. That thing absorbs the energy and then transfers it to your sample, which ionizes it. CI is like chemical ionization, where you
When you
ionize
ionize something in
something.
chemistry. Using chemistry.
Yeah, you
Okay.
ionize something like a molecule, which then ionizes the sample, which is
That makes sense.
better for reasons. EPCI is just another type of that, and photoionization is, you know that you just shoot a laser directly at the sample and it ionizes it, which only works on certain samples. So after you've ionized it, you want to analyze the mass, and so you know very well time of flight mass analysis. I've actually got this in space and this in time thing backwards. It should be the opposite way around, obviously, because time of flight is not in space, it's in time. But so you know time of flight very well, where it just is travel time. Orbit trap is a really cool one where it like
It sounds cool.
it goes into like it's like an electrode that's like cylindrical, with like a cylinder in the middle and an outer cylinder around it. It goes in and it spins around the electrode, and you can measure the oscillation frequency of it as it spins. And FTICR is what does ICR stand for? Trying to remember. Ion cyclotron resonance. That's it. It's kind of the same as Orbitrap, but it uses like a magnetic field instead. And it's not like a cylindrical thing. But they both kind of do the same thing with like frequencies. In space is a easier one, basically. So this example up here is called quadrupole, where you literally just have these poles of electric charge, which you oscillate their charges, negative and positive, and your ions that go in will either be allowed to pass through or they won't be, because they don't resonate in this thing at the right frequency. And so what you do is you sweep through different voltages and oscillation frequencies on these poles, and at each different value, a different mass to charge ratio of sample will be allowed to pass through, whereas everything else will get ejected out the edge or hit the poles or whatever.
That's just really cool.
Yeah, so it's like it gets a specific angle to go through, and only something that resonates at that specific like voltage and frequency.
That's maddening. My goodness, who even thought of that? That's insane.
I don't know. QIT, LIT, those are quadrupole ion trap, I think, and linear ion trap. These literally trap it, like it actually, you can literally hold it in space between a bunch of poles, and then you release it. You can release at any time individual mass to charge ratio samples. Or I'll say masses for simplicity, but like your samples are all held inside these poles, and as you adjust the, I think, frequencies of the poles, certain masses will be allowed out at different times. So you can literally just select which ones to eject from your trap. Magnetic sensor, it should be sector, not sensor. This is like the one we're taught in secondary school, where it's like it just travels around a magnet, and the ones that are heavier will just not get deflected as much by the magnet, and so it hits like a detector in different locations based on how far they've been deflected by the magnet that they've passed by. It's really hard to describe without like a diagram, but I can show you later. And then to detect them, you have don't really want to go
Typical
into this.
ones. I mean, electron multiplier,
we've
photon
talked about
multiplier.
this.
It's just amplifiers of different kinds.
Yeah. Essentially, you need to get light at the end, and then you take a photo of it or whatever. That's pretty much it. And so, what we're going to focus on is native mass spectrometry, which is essentially doing mass spec in a way that's not going to affect your protein very much.
Makes sense why you would want that.
yeah. Because denature means like essentially the protein unfolds, because proteins are usually folded in a certain way for their function.
I told you I know proteins as folding chairs. Yeah.
And so it's very easy to unfold proteins, like temperature or charge or like pH, like literally anything will just unfold them if they're not optimized. And so doing this is great because it lets you then study what the proteins are doing with the things that are bound to them. So we call ligands, biochemists say ligands are the things bound to proteins, whereas chemists say ligands are the things bound to metals. But yeah, it means you can look at what's attached to the proteins. And so in our case, it's obviously iron sulfur clusters, but it's also useful for like drugs that are acting on the protein. Cofactors are like molecules that just help the protein. Lipids are like fatty molecules. Nucleotides, I can't remember. DNA and RNA are DNA and RNA. You know about those. And these all interact with proteins. So you get to look at this with native mass spec. And the reason we can do this, and the reason we couldn't do it before, was because a lot of these methods would denature the proteins, whereas now advancements in electrospray ionization mean that we get more control over the conditions that our sample is in when it goes into the spectrometer. So that's things like pH and solvent system and all that, which is great because in the case of iron sulfur clusters, they kind of break apart in acidic conditions, and so we get to avoid that completely and look at them in mass spec bound to proteins, which is great. So this is a raw mass to charge spectrum of our protein, our FNR, the fumarate and nitrate reduction, whatever. And this is the raw spectrum we get, which is quite complicated.
I mean, it kind of makes sense that it will be spiky. I don't know if I'm understanding it correctly, but
yeah. So the spikes here are for the different charges of our sample. Because in the electrospray ionization, you're not just getting like individual +1 charged proteins, you're getting like +2, +3, +4, +5. You're getting like every charge basically. And so you get all these different spikes because we haven't separated it by charge yet to get just mass. This is the raw mass to charge ratio spectrum. And so there are three main regions here. One is the single monomer protein. So monomer meaning it's just one protein by itself, with its 4 iron 4 sulfur cluster inside. Then you get the monomer without the iron sulfur cluster, which means it's kind of been lost in the mass spectrometer, just got yeeted away at some point. And then you also get the dimer, which is how it's naturally meant to be found.
If monomer was one, what's gonna be a dimer?
Yeah, crazy. And so the dimer is how it should be found biologically and naturally, but the process of the whole mass spec thing breaks off a lot of monomers, which is actually really useful because looking at dimers where you've got double everything in mass spec isn't really great. Like it becomes confusing. You're not sure about the data you're looking at.
You say that dimer is the way it's found. Does that mean it's...
As in biology, like in your cells, it will be 2 proteins stuck together.
Is there any relation between why dimer is like easy to find naturally and why the graph is like really chaotic when it's a monomer?
What do you mean by chaotic?
Like, okay, I know, you can see the graph. I think.
I mean, yeah, but I'm not sure what you're referring
is there,
to.
Like, is there? Yes,
shape?
yeah. Like on the with the monomer, you have a shit ton of spikes, which are well, they're going from a crazy high to a crazy low. With a dimer, it's well, with the spike, you have first of all fewer spikes. Second of all, the spikes are less pronounced. I'll just say. And is the relation between the reason why?
I'm not sure. I don't know.
Okay.
Yeah, I'm not sure what produces the different intensities on this, or why this has so many spikes and this doesn't. It could just be. I'm not sure.
That's fine. I don't know. Just
yeah. So that's the raw spectrum, but we want to look at the actual what the cluster's doing, and so we can do that by, for one, we take a slightly different version of FNR where this just It's called S24F. This is basically the same thing, but it just does its function slower in the presence of oxygen, which is great because then we get to see how oxygen changes it. And so this graph on the left is just that monomer region that we saw before. So this whole bit here. We can look at this and we can see that at 0 minutes of oxygen exposure, so before oxygen, you've got mainly your 4-ion, 4-sulfur cluster here.
And
But
after the exposure,
afterwards, it's broken down into a bunch of different smaller clusters, and you've got loose sulfur as well, which is really cool because that means you can actually see that oxygen is directly breaking it down, and you can see what it's breaking it down into. And this extra bit here, I think, is just from like extra stuff attaching to the cluster, which isn't very important. But yeah, so this
That is
shows us
cool.
the degradation. And then this here is that dimer region from before. And what this is showing us is, so you got the same kind of thing where you start with your clusters here, and you've also got a couple versions of like 3-ion, 3-sulfur mixed in. Basically, these are low abundancy. These are basically, this is the main one. But you can see that when we add our oxygen, it doesn't really make more peaks. You know, there's a bit of nonsense down here, but it doesn't really make more peaks. But that actually makes sense because what we know is that when this, when the cluster breaks down, the dimer splits into a monomer. And so you shouldn't be expecting any dimer here. You actually,
that does make sense.
goes
Okay.
all the way over to here.
Oh, that does make sense. So,
And so
if
this
you,
is-
so
yeah.
the graph on the right, if you just, if the mass was just much wider, as in if it went from 29,000 Daltons to 60,000, then after you expose the dimer to oxygen, you would expect just to get twice as many monomers as you got the dimers, and the same graph as on the left, except with the
Yeah.
lower mass, because obviously it's monomer that's
Yeah.
half the mass.
I think it might already be doing that because I was looking at this, I was like, why is the red peak here the same height as the black peak here?
What the heck?
So it might already be doing that, or it's just normalized to that. I'm not sure. But yeah. The thing I forgot to point out on this as well is that this isn't the same kind of graph as the previous one. So this previous one was mass to charge ratio, but this new one is just on mass ratios. So you can actually computationally get rid of the whole charge thing and just focus on mass.
Yeah, there's
And so
Dalton.
that's what this is doing. It's a lot easier for analyzing. DA here means Daltons, which is just a measure of mass that biologists like using because they don't like doing actual like atomic units. They just say Daltons and
Isn't
leave it at
Dalton?
that.
Isn't Dalton? It was like a weird rescaled. I think it was either atomic mass unit
Yeah.
times 10, or it was I think nanograms
It's something like
times
that. I can't
100, something like
remember.
that.
Yeah. But does this all make sense?
Yes, this all makes
So
perfect
this
sense.
is
as well.
really cool.
It really is.
And and what we can then also do is check that we've labeled our peaks correctly, right? Because like you look at these, you're like, well, how do you know that this is the 3-ion 4-sulfur one, right? Like just from the mass, you're not sure which is which. What you can do is you can actually replace the sulfurs in your sample with heavier sulfurs. So normally sulfur is the 32 isotope, but
And
you can actually
change it.
go in
That's
and replace it with
genius.
34. And so that means that then a cluster that has 4 sulfurs will then increase in mass by 8
That
because
is
you've gone up 2 for
So
every sulfur.
dumb and genius at the same time. Oh my
And so
goodness.
you then get to just look at all of these. You're like, well, this goes up by 8, so it's got 4 sulfurs. This as well. This goes up by 6, so it's got 3 sulfurs, and so on. This lets you like confirm that you've got the right peaks labeled.
That's so dumb and
and-
genius at the same time. I love it.
I forgot to say, but apo means like you don't have any cluster bound, and so obviously this one doesn't move because there's no cluster in it. So this is just the protein by itself.
Mhm.
So yeah, that's pretty much it. That's yeah. I don't know
Wait,
how
so-
long it's been.
Hold on.
but-
So basically, because okay, so the concept here is that when you have, if I understand correctly, when you have DNA, right, you want the basic idea was that when you the basic problem is that when you have DNA, you want the cell to switch from breathing without oxygen to breathing with oxygen.
You are now breathing manually.
Yeah, exactly. And so the way it's done is by degradation.
Fuck you.
Yeah, Timon is really sensitive to that kind of stuff, like breathing manually or like blinking manually or I don't know, just realizing that your arms are
It makes the
awkward.
cell breathe.
Yeah, and so basically, the way it's done is that if it detects oxygen, it's not like obviously the mechanics is if it detects oxygen, it should switch to breathing oxygen. But how the mechanic is actually done is that if oxygen is there, it causes it to degrade. The gas degrade.
So the cluster degrades, and then the protein,
does it
the dimer
degrade?
splits into monomers.
Does it degrade from a dimer? Oh yeah, okay, never mind. I was
So
about to.
the cluster goes from 4 iron 4 sulfur into 2 iron 2 sulfur.
I was about to ask if it
And
degrades from a dimer
this
to a
affects the
monomer.
protein. It something chemistry magic. It just makes the protein deactivate and split off into its individual pieces.
That
and
makes
unbind from the
so much
DNA.
sense. And so then, okay, and so basically, okay, that makes a lot of sense. I don't think I have any questions. I mean,
Really?
I might miss something because I mean, I don't know. Hold on, going back to the graph of dimer versus monomer of after
This or
this one,
this?
yeah, no, this one, yes, right here. So I'm looking for questions, but I can't find any. No, I'll be honest with you. I just get it now.
Let's go. That's perfect then.
I mean, yeah, I really do. Oh wait, actually, one question then, I guess. Because I haven't noticed that before. Does the dimer require a longer time to break down than the monomer? Because for a monomer, it's 18 minutes. And for a dimer, after 20 minutes, the peak is only like half the size. And then after 80 minutes, it's only flat. So I'm guessing that means that after 80 minutes, all of the dimer is broken down into monomers. But after 20 minutes, not all of the dimer is broken down. So do dimers require a longer time?
I would assume, yeah, from the graph, like you've described, but I actually don't know. It could be that the monomer is... I'm trying to remember the way this data was gathered, because in theory it's like... I'm not sure how they did it, right? Like if they had it in a sample, introducing oxygen, and then they went and put it in the mass spectrometer. Because the thing to remember is the monomer doesn't exist normally. The monomer gets created in the mass spectrometer. And so that means it's all dimer anyway. But then you put it in and some of it becomes monomer.
Oh, so if they did it last second, or if they somehow forced the monomer to exist
it could also,
using witchcraft.
actually, if you look at the 18 minutes one here, you still have the red peak here. Like there is still this much around. Because intuitively, I would think that it doesn't make a difference with the time.
They just left the monomer in there and they just added all the rest.
Yeah, I'm not sure. I would have to read the paper a bit closer.
That makes sense. I don't know what to tell you. just get it.
You just get it. I mean, that's
It's a
that's
good
perfect.
explanation.
That's literally like that's the goal, isn't it? It's like give a talk and
Actually, hold on. In that
explain
graph,
everything.
there was S24F. I don't know if that.
This.
Yeah, was S24F because
It's just a category of F and R. Like it's a
Oh, never mind
specific
then.
type of F and R that's like really slow.
for a second I thought of
so
like
we
you
can-
had 24 sulfur and the fluorine just holding
Oh
it
no,
together.
I did see that. Like, once I looked at it, I was like, 24 sulfurs. What are you on about? And then I realized, oh, that's the name of the thing.
Yeah, I was just curious. I was just curious. I don't know. I mean, if you can have hexafluorides or heptafluorides, then maybe sulfur also has some fun properties. I was just curious. I also do have to say I really like the color. I know I've mentioned that before, but
Oh, yeah,
but
thank you.
the color is like at the end the blue one it's whatever, but at the very beginning the red and yellow is really nice.
Yeah, the red and yellow is like, I've got an opportunity
Just
here.
perfect.
Cool. Yeah. I mean, I don't know what else.
Well, there we go.
I wanted
That's
to have a bit of like practice with the presentation.
I'm glad I could help.
It actually really helped, like talking to someone who doesn't know anything about this. Like you don't even know what proteins are, pretty much.
Well, I mean, it hurts, but like you're not wrong.
Yeah, I mean,
It hurts because you're not
what do
wrong.
you imagine when I say like it's bound to a protein? Like what do you picture?
Bound to a protein. Well,
Yeah,
I picture
like
a
cluster bound to a protein.
I picture a protein, which is I picture it taped with duct tape to a folding chair. To be honest, so that's is that
Actually, I mean,
close?
I showed it, didn't I? I showed it.
Yeah, this
Like
one.
here, you can see the cluster in there.
Well,
but
I
it's
don't
like
know. I don't know what bound means though, because I'm assuming it doesn't mean
Okay.
bonded, right?
It kind of means bonded, and it
Oh,
kind of
never mind.
doesn't. It's like
Is it bonded
It's
in
like a-
multiple places?
it's not a covalent bond. Well, actually, okay. In this case, it is a covalent bond. You can see it. So these are the cysteines, and that's a covalent bond to the iron.
Wait, is it like bonded in multiple places? As in, you don't. As in, it's not a bond, but it being bound is made up
It's
of
being held
bonds.
together.
Yeah.
In this case, it's literally just a covalent bond. But I mean, I don't think it's a very strong bond. I think it can break, and that's why we see it like in the other graph. We see that some of it just falls out in the mass spec. It's just literally the cluster leaves. It's kind of usually with proteins, it's just electrostatics. It's like you just have something. You have something that just attracts a certain part of the ligand you want to put in there. In the case of this, it's like the iron is looking for more sulfurs, and your protein is sticking out a bunch of sulfurs here. So it's like, oh, thank you very much. I'll stick to that. And so that's literally it. Yeah. Does anyone else have questions? I mean, I've done all this prep. I need to answer some questions. No.
Yeah, the downside here is that, well, I mean, I don't know what the upside would be,
Is
but
that no
the
one
downside.
cares?
Well, no, it's not really that no one cares. It's just this is heavy chemistry.
This is biochemistry.
Considering
Basically.
considering how more organic chemistry videos are performing, like this is you're playing with a tough crowd. I'm gonna get on there. I'm gonna just trick people into watching chemistry videos, whether they like it or not.
One thing I forgot to look up is how do you actually replace the sulfurs? Because a problem you run into is like, how do you replace the sulfurs in the cluster without replacing the sulfurs in the protein? So I need to look that up.
Oh, that's. Wait,
I think
when you
it's probably really easy.
hold on, when
It's
you
probably not a big deal, but it might be asked by someone.
having taken one biology class, I feel proud for mostly understanding what's going on.
That's good. I hope I
enough.
explained it like quite well.
You did explain it really well. I mean, you made me understand, so that's like it's not an easy thing to do.
Yeah, but you have like a base level of some chemistry.
Yeah,
knowledge.
in theoretical chemistry, going from quantum mechanics, this is biochemistry, okay?
Mm.
You're basically it's kind of like I don't know,
It's
explaining.
biophysical, actually. That's the name, the official name, biophysical chemistry. which
That's
is just-
wild.
It's like every discipline in one, I guess.
Anything from physical up to biology. It's like starting with I mean, the fact. Okay, to be fair, you did chuck spin in there in orbitals, which I mean,
I know. I really don't need this slide. I
This
just put it
scale.
in because
it's a wild.
I need to find a reason why this whole like low spin cluster is relevant. Because right now it's just there. And I kind of segue into it. I'm like, okay, well you have mixed valence, so it means all of this. And then I go into this. I'm like, yeah, so the mixed valence means you can do this. So it's like, I've said this is useful, but I haven't, like, none of this is useful.
Hold on. So okay. Okay. Does it? Wait, it doesn't affect like the because the delta there. Actually, well, I understand what the delta means, but what changes the delta? Is it the
What changes it is the ligands. So the stuff that's attached to the ion.
all right.
So in this thing
Ligand
is called
changes the
like
delta.
ligand field theory or crystal field theory, and there's literally like a list of high to low ligand strengths, whereas like the high strength ones will give a big splitting, and the low strength ones will give a small splitting.
Wait,
And sulfur is quite a low one.
do ligands attach it? Wait, do ligands from a protein attach it to the protein?
Do ligands what? Sorry.
Do ligands attach it to the protein or not?
No, ligand. Okay, so this is where it becomes annoying with the terminology, because the chemistry term for ligand is something that's attached to a metal, like a metal center.
Right.
But the biology term for ligand is something that's attached to a protein. And so in this, it's
okay.
like,
So wait. So,
so
in
in
this
this
case,
context, we say the ligands are sulfur, but in the other context, we say the cluster is the ligand to the protein. So it's like,
oh yeah. Okay. That's what confused me. Okay, that's
Yeah.
fair.
yeah.
All right. So you see, I was thinking that the ligand was okay. So it's the other way. So sulfur is the ligand for the delta,
Yeah, it's a ligand to the ion. To the ion
and in this
centers.
case, does that mean that like you would need to switch it to a different atom for the delta change?
Yeah, if you
or-
had different ligands, like what's a high field ligand? I think water. If you had like water just stuck to the ion, is water a high field ligand? Let me just.
I mean, I'll be honest. In this case, then I have no idea how you're gonna relate this back to biochemistry because then then set you rough.
Okay, a really high field one is carbon monoxide or carbonyl. If you had an ion with surrounded by carbon monoxides stuck to it, then this gap would be massive, and so then you'd have a low spin ion center.
Yeah, in that case, I have no idea how to relate it because I mean, my hope was that maybe there's, I don't know.
Well, I mean, yeah. The main thing to relate is why low spin cluster matters, and my professor mentioned this, so I was like, okay, well, I'll explain this, but he didn't actually like say why this is relevant. So I need to like.
I really like the fact that this is basically the same. I just imagine the professor talking with like a friend of theirs about, you know, before presenting to your class, you know, just talking with them like, oh, in the lecture I'm giving, I've actually planned on mentioning this low spin cluster, but I can't relate it to anything. And so then they just, you know, mention the lecture that related to anything. And then next step down the line, it's you making a presentation like, oh yeah, my professor mentioned this low spin cluster. I don't know how to relate to anything. And then someone who sees your presentation will then explain it to their friends, mentioning the low spin cluster. No idea how to relate it.
Yeah. The thing is as well, like he didn't explain any of this. He was like talking about it, and he said, "Oh yeah, something. The ions are high spin, but the cluster's low spin because of a special thing called antiferromagnetic coupling, which I'm not going to explain." And
I
so
mean,
then I'm
it's
like,
pretty
"Oh well, I
self-explanatory.
know this. Let me go and explain it."
I mean, that makes sense. Hold on, but the delta, that's between
between
iron
this
and
and this.
sulfur.
No,
No.
the delta is
So-
so these white
so the
lines
ligand-
are the d orbitals in the ion.
Yeah, that's precisely why. Because so this is between because the antiferromagnetic coupling is between two ions.
Yeah, and so what this does,
And the
this
ligand
goes
affects
between a
that-
sulfur.
Oh, that's actually
So
really
It's
cool.
actually mediated by a sulfur.
That's really good. So So sulfur affects, well, not really that sulfur affects, only sulfur is responsible for the coupling between the two ions.
Yes. And
That's-
so it's also the reason why it's antiferromagnetic and not a different type. I mean, usually it's antiferromagnetic, but
That is cool.
oh, I need to show you the diagram for it because it's really cool. But it's literally like the spin in the ion affects the spin in the sulfur, which affects the spin in the other ion. And so it's coupling one ion to the other one through the sulfur. And the kind of order of spins means that the spin on one ion subtracts the spin on the other one.
That makes sense.
So I think it means that they align anti-parallel. So if one ion is spin up, then the other one will be spin down. And so they cancel out. Whereas if you had ferromagnetic coupling, then one ion would make the other one be spin up, because it make them both spin up. And that would then, in this, it would mean that the 9/2 spin state is the lowest one, and the 1/2 is the highest. So it's favored for it to be a high spin cluster. Yeah.
Right. No, I have no more questions. I mean, I'll be honest.
Epic. That's, yeah.
Sorry, Timon just did some art of me fighting with a mole, so I mean...
Is it like an actual mole, like the animal?
No, there's someone... Timon, is that you, Timon? The mole lover?
Yep.
That's you, yeah. Yeah, then I mean, that makes sense. I have a fire hammer, that's cool. I can't really imagine you having a t-shirt that just says fucking love moles. Well, there we go then.
Yeah, I mean, I'm glad it went well.
Yeah, I'm glad I could help. I'm sorry for not being able to ask more in depth, but I mean, biochemistry, that's way out of yeah.
Yeah, it's a yeah.
With theoretical,
Because
I
the
could try,
biochem
but...
people I was presenting to started asking me questions about like the proteins. They were like, "Oh, well, is this expressed in E. coli or is it just found native?" And I'm like, "What?
You
What do
need to hook them in with the orbitals. You really do. You really need to hook them in because they won't know shit about that. So there's
That's the thing.
plenty
Though,
questions.
they look at it, they're like, "Oh, this is like chemistry. I don't care about this."
Biochemists just look at, oh, this is chemistry. No.
Well, that's the thing. Like they care about proteins, but when they like draw molecules, they draw blobs. Like they don't even draw the molecules. It's like, they draw proteins as like just a chain of blobs, and that's like as in depth as they go.
It's always so funny to me as an outside observer to see always the people from lower abstraction fields talking about people from high abstraction fields because it's always the same. It's the
same.
exact
like,
same. It's the exact same as
spin as arrows. Like, what do you mean?
Yeah, it's the exact thing as Reblax constantly shitting on physics. It's the exact same thing. Except you go higher and higher up. Reblax is shitting on physics, Remco is shitting on chemistry, you're shitting on biochemists. We need to
really
get
funny.
someone from biochemistry to shit on biology and then them on medicine. That's just the way things go. Because it's always the same one where basically you have this like hyper specific, you have this extremely cool explanation why some very specific interaction happens, and then you have the person from the higher abstraction like, okay, but I mean I don't care about that interaction because it happens 100 times in my case, so you really need to hook them in with the orbitals.
I'll see what I can say about this spin thing. I think my 2 bullet points for like improvement are link the cluster spin and also explain how to replace the sulfurs with the isotope.
The charge to mass one, that one, I get why it's there because obviously you were just talking about the actual experiment. You need to link it through charge to mass to actually the charge to mass graph. Because I mean, you obviously need to link it through charge to mass to actually get to the interesting 2 graphs. But that one just, I'll be honest, I just only mostly acknowledge it as like, yep, that makes sense. It's charge to mass.
Yeah.
Because the next one was really cool. I really like how it separates from a diamond to monomer.
Yeah, it's really cool. because it also then proves that in order for it to, like, when it deactivates, it's literally breaking off from the dimer into monomers.
That's actually wildly cool. I mean, because it's one thing to say that obviously I keep going back to the breathing, but like it's one thing to say that the breathing switches to oxygen breathing when when there's oxygen. Like that's obvious. Clearly, when there's oxygen, we breathe oxygen. But it's another thing to be like, oh yeah, it's precisely because it switches from a dimer to a monomer, and that just does a witchcraft on the
Yeah.
just a biological witchcraft. Oh, because then it could be another question. Actually, I'm bad at asking relevant questions because I just don't know the topic. So all my questions are going to be kind of, But is there a way to achieve to break in the same way without oxygen?
I think, does nitric oxide degrade it? Trying to remember what I read about nitric oxide.
I would just like to mention that this is basically how to make a poison with Make It today.
Well, it's more the opposite. It's like, okay, so this is, for one, this is in bacteria, not in human cells.
I mean, okay,
but,
that's fair. Never mind.
How to make
it
because
antibacterial?
it like makes you breathe, right? Like it's
Yeah, but I mean, if you do it without oxygen, okay. But however,
yeah, I don't know what happens if you breathe without the oxygen.
I mean, if you have bacteria, a whole bunch of them, if you then give them something that will cause the dimer to break, then they will switch from. I mean, there has to be a reason why they switch between different forms of breathing in the first place. So at the very least, it's less efficient. Which means, at the very least, it would cause them to hibernate-ish or slow down with less energy, whatever. Not they don't be oxidizing. That's actually really wildly cool, I do have to say, because I mean, just having the explanation for how a bacteria is even bacterium, whatever, no one cares. How it's even able to switch, like the actual explanation.
Yeah, it's really
from
cool.
A fucking chemical reaction that's responsible for it. Not even an organelle or anything. A chemical reaction.
Everything is chemistry when you look. Like...
Yeah, but I mean, but that's precisely my point. When just in biology. Obviously, everything is chemistry, but
it's
in biology,
crazy that we can even look that closely into it.
Yeah, exactly.
And, like, identify. Like,
that's exactly what I'm
this
saying.
This is
because
literally like why it switches breathing.
Yeah, because for example, if you get a paper cut, then you think of it as paper cut, and you think of it as cells, coming together to fix it. But you don't think of it as a chemical reaction that happens to fix it because that would be too complex. So seeing an actual biological process inside of bacterium. Whatever. Seeing that actually happen because of a chemical reaction is wildly cool.
Yeah, I agree. Even though I'm not a biophysical chemist.
What's the difference at this point? Biophysical chemist. I mean, just might as well just chuck it in there. I mean, if you're doing this presentation,
if what I was doing was on like proteins, then it would be biophysical chemistry. So my friend, she's also looking at PhDs, but she does, EPR.
Electromagnetic. No wait. Is it paramagnetic resonance?
Yeah.
Oh my goodness.
So
yeah, I don't know.
Electrons, like the
electron paramagnetic resonance.
Electrons.
Fuck, it was right there. Damn it, I forgot what the E meant.
She does EPR on like proteins, basically. Like she sticks things onto proteins and then does EPR to track what the proteins are doing. And the things she sticks on are like labels for the EPR to follow. And she also looks at things like binding to proteins and all that. And so that's like biochemistry, biophysical chemistry. It's like a bit of both.
Actually, I have one question for you. It's unrelated to the thing, but I've been curious about this. When it comes to isotopes, are different isotopes, do they really have similar properties to atoms? Like when you have different isotopes, do the chemical properties change very much?
Because in the case of chemistry, it like doesn't really make any difference if you have a couple extra neutrons.
The reason why I ask, because I find it hilarious that we can even do this, but basically when you wanna see if certain atoms are responsible for something, what I've seen chemists do a lot is just use an isotope, and like then
deuterium labeling is a really common one.
Yeah, I think something with carbon in one of the studies I've seen done with, I think, carbon.
With carbon, what, like carbon NMR or?
Oh no, it's just no. What I mean
labeling.
is like when basically, I think it might have been with bats. Was I even looking? It doesn't matter. The point is that basically, when you add into some kind of system a whole bunch of atoms and you want to figure out where they end up, what I find hilarious is that the way I've seen it always done is you just use isotopes of those atoms, and then you just check, and then at the very end, if you have a carbon atom, there's a normal carbon atom, then you know that's not your atom. If it's an isotope, however, then you do know that this the atom that you started with. So
oh yeah. No, yeah.
And I find it
usually you do that with like NMR or something.
Yeah, I find it
it's really cool.
I just find it so hilarious that you can just mark your atoms, you know, just how you have birds, you read often mark them by clipping a tag to their leg, you know, figure out where they are. You just do that with
a different
atoms.
Type of the atom. It's like a different color of it. You just
and it's
just put a different color atom in. And
it's mad. It's madly cool. No, yeah, I just want to ask if isotopes really are that similar, because I mean, on one hand, it makes sense that they would be similar.
In chemistry, it basically just doesn't make any difference.
Yeah, it makes sense.
The only thing is, like, if you drink only deuterated water, then you eventually get health problems. But like other than that, it's really doesn't do anything. Except for radioactive isotopes, obviously.
I mean, there's just extra helium, you know. No one minds that.
And it breaks down into completely different elements. Yeah.
Yeah, but I mean, okay. I feel like if you're getting radioactive isotopes into your system, even if they didn't break down, I don't think that would be great for you. Like yeah, something may break down into lead, which you don't want. But even if it wasn't radioactive, having a whole bunch of, I don't know, radium in you, even if it wasn't radioactive, it's that.
Well, I mean, what else is dangerous about radium except for the radioactivity? I don't even know like, what the hazards are aside from the...
Yeah, but I mean, wouldn't there be like a different kind of like heavy metal poisoning?
Well, only some heavy metals are poisonous. That's the thing.
Oh, fair point, I suppose. So, you still wouldn't want them in you.
Yeah.
You still okay. Even if some heavy metals aren't poisonous, you still don't want them in you. As I would argue.
Well, let me look at.
What? Why would you say well to that?
Yeah. There are definitely platinum drugs.
I guess platinum chemically in that
platinum
would make
drugs.
sense.
Gold nanoparticles are used in biomedical imaging.
Can you not get gold heavy metal poisoning? Actually, no wait. I don't think it was heavy metal poisoning, but I do remember that you can get poisoned with gold. Because it happened on one episode of House where a girlfriend of a certain guy was poisoning him with gold, and he figured it out because he like added a certain chemical on her hand, they turned purple, which is a trusted source of information. I would never doubt House.
I'm actually really hungry. I actually haven't had dinner.
I'm really tired.
Are you gonna end stream now?
I don't know.
Isn't this your second stream today?
Well, if I go on for another 26 minutes, then it's gonna be tomorrow's stream.
Then it's tomorrow's stream.
Yeah, exactly. Technically technically in your time zone, isn't it tomorrow's stream?
No, I'm an hour behind you. Not ahead of you.
Damn it. I think I could just call it. I mean, I am gonna change it now because I mean, I'm just gonna keep going. It's the second one. For the first one, my GPU crashed because that's always fun.
Oh.
Yeah, just my PC. I like it because my PC just sometimes gives up. I'm just switching transparency in Blender and just like no, it's over. It's a complex of a calculation. I'm done. Ends off.
Okay, well, I'm actually gonna go and eat because
Alright.
it is almost 11
Bye,
and I
Fred.
have to be up at 8 and I need
It's
to
fine.
eat at
I
some
get it.
point.
Bye and good luck on the presentation. See
Thank
ya.
you, thank you.
Bye.
Bye-bye.
Bye.
Ah, well, house is 1000%
go too.
medically accurate. Yeah. Bye, Etidon. See ya.
Okay, bye.
Don't what?
Huh?
We just said bye.
Yeah.
No, okay. Bye.
See ya. I'm so tired. That's fine.
Then end the stream and
No, but I really want this to be the tomorrow stream because I don't know how well I'm gonna stream tomorrow, and I would just rather, just in case, have a stream. I'm gonna make a thumbnail for the stream. I just need to call it, change the number. Yeah. Okay, this and this and this. And this. What's
I'm
need to?
trying to get Akinator to guess you, and Akinator is just asking your hair color for the third time.
I don't think Akinator knows me. I don't even know what Akinator is. My God, that's such a weird thing.
Why wouldn't like?
Is it that popular?
I don't know.
I don't think it's.
just know it.
Where does Akinator know things from, actually? How does it work? What was the science behind it?
I don't know.
Magic, witchcraft, I'm assuming. It has to be, as always. It's always witchcraft. There we are. I've barely done any work for the video today. Fuck me, I've only done one page. And I wanted to finish in 2 days. In order for me to finish in 2 days, I would need to do 3 pages tomorrow. And then 2 pages in 2 days, and then finish it. That's doable. I can do it. I can make it. It's fine. Whatever. So many fucking. Well, I think I'm gonna call it a day for today. You know, might be it.
But then change back the title.
In like one time zone next to us, this is gonna be tomorrow's live stream, and I'm doing global live streams anyway. I've been doing American streams, which are 7 hours early technically. Also, I've been doing, actually 7 hours late. I've also been doing streams just 10 hours early. That don't matter. The idea is that on average, this is a daily live stream, which I mean, so far it is.
Yeah, it's just as long as there is no longer than a 24-hour skip.
No longer than 48 hours. It can be 24 hours if you want.
No, it cannot.
Yeah, it can be. It can be midnight in one time zone up to 11 p.m. in another time zone.
No, but it's not a. No, it's.
Okay, so here's the thing. If I stream at 1 a.m. in Poland, right?
Yes.
And then the next day I stream at 11 p.m.
Yes.
That is 47 hours in between 2 streams.
All right. True.
Yeah, so it actually can be longer than 24 hours.
But then you can just hack the system and make 2 daily streams, pretending to make daily streams. So let's just say
Yeah, instead of doing daily streams, I am doing 2 streams a day per 2 days. I mean, no, not today. Hold on. Instead of doing daily streams, I'm doing 2 streams per 2 days. Consider the system hacked. I don't have a schedule for this. It's getting exhausting. Fucking daily. Can you imagine?
No, it's like I have no idea how you do it. Honestly, I honestly have no idea. Like,
The past, that's fine, but the thought that I'll have to do it in the future, that's what's bugging me. Because I can't just end at, I don't want to end at 1,000. I might.
you can just I don't know, at 1,000 you can just say that you skip a week and then continue.
No, because then wouldn't be, no.
Like, this is like quite a burden. So
You're telling me? I've been doing it for 2 fucking years!
I don't know how. I can't even brush my teeth every day for 2 years.
Lack of social life. That's how you do it. Once you don't have that, then you just have a lot of time, and you kind of you have a big hole in your day. You made the schedule, you can break it. I know, but I can't. No. I shouldn't break it on an odd number, right? I would need to do it on 1,000. But then should I stop at 1,000? Gambler's fallacy, basically. One of them.
You should do a break at not 1,000 but 1,024, because like base 10 is so arbitrary and base 2 is less arbitrary.
Oh, it's sunken cost fallacy. That's the name of it. That's the name of the fallacy.
Good to know.
It's when you give something more value just because of the cost you've sunken into it. In my case, the costs are 2 years, my life. You made a schedule, you can break it. Yeah, I can make it, so I can break it. You know what they say. That's a saying, and now it is. If you can make it, you can break it. I put down the t-shirt. My goodness.
Or for 1,000 you can just not stream, but buy a bunch of airplane tickets and basically follow the sun for 24 hours and take off at a lot of airports where you can meet up with fans.
I mean, I am certainly gonna do something big for 1,000. That's certain. Just don't know what yet. Don't have an exact plan. Just plans. Well, anyway, y'all. 3-hour long stream. That's better than the last one, because the last one fucking crashed. GPU crashed. I'm feeling really tired. It's been a long week for me, mentally draining.
Get some rest. Get some rest.
Rest ain't gonna help. But just sitting here ain't gonna I'm gonna be tired the other way. Anyway, for now I suppose that'll be it. Thank you everyone so much for watching and have a great day.